Good afternoon. How you guys doing? So I've got some audio jankiness because of reasons. I started up my stream computer and realized that there's a weird, like, clicking with my interface. I don't know why it's there. If you listen real close, you can hear it, but I can't get rid of it, and I don't know why. It's not any of my outboard stuff. It's the audio interface. So that's cool. How you guys doing? Welcome. How's your weekend? Okay, I need to change that. I don't want to see myself over there. Okay, so we're getting back into some StudyBox stuff. Specifically tonight, we're gonna have a look at a closer look at these scripts and approach the reverse engineering from a slightly different angle this time. We're gonna look at the scripts and use that to try and figure out kind of like what they're doing, and then go back to the disassembly and piece things together or whatnot. Right? So I wrote up this little program real quick the other day. By the other day, I mean like 3 weeks ago, I think. All it does is it has a look at these guys, which are the script data chunks in the tapes. It takes those and disassembles it into what we know so far, essentially. Anything that is unknown, it just says, yeah, it's opcode, whatever. We'll get there. So we're going to see, or try to see anyway, how some of this stuff works and pieces together and all that kind of stuff. So this here is the very first script that is run, as far as I can tell, on the StudyBox English tape, the one that we've been looking at. And this is probably for like some setup stuff. So this isn't a very, very large one. One of the larger ones, if I go and have a look at this one, that's a larger one. Yeah, so some of the larger ones do a bit more things. You can see there's actually some strings in here too. But they're absolutely littered with the control characters and stuff I can see. And stuff like this, which is just I don't know what's going on there. Yeah. So yeah, this is probably a control character of some sort though. XBB. Maybe. I don't know. We're gonna hopefully find out some of this stuff. But yeah, that's where democracy. After stream, probably. Believe me, it was tempting. It was very, very tempting, but I decided not to. I'll be doing that after stream. I played it all day yesterday, literally all day yesterday, and I found out that I like sneaking around with a sniper rifle and an autocannon. It works really well, but we're not getting into that tonight. We're not on stream anyway. Okay, bye. Anyway, so this first script doesn't do too much, obviously. Disable sprites, but puts some random crap on the stack. Actually, does this one take what was that? E5 byte code $E5. One argument, no results. Okay, so that's 0. All right, so this 3096 is just being put onto the stack for someone else to use. Okay. 9D takes 2, right? I was looking at that one earlier, just before stream. Byte code 9D. 2 arguments. All right. Yep. So 3096 are still on the stack. Pushes a word. Opcode E3. What does that one do? Byte code E3. One argument, one result. Where does that push actually put stuff? That push word. You know, I think I want the bytecodes in all these. God damn it. So the way I'm doing this, by the way, okay, well, yeah, there's that. I want instr-map. Go to that one. Right. So I'm basically going through every byte, looking at the instruction, seeing how many inlines it has, arguments, and some other stuff, and then just printing it all out. So this is the big structure of where I'm defining all of the instructions. I don't use half of the data in here, but first one is the bytecode. Then it's, what is it? I don't know. Where do I define this? What do I define instruction? Oh, there it is. Yeah. So first is the opcode, the argument count, the operator count, the operands, the inline count. Null terminated, count at the first, and then count with an additional word at the very end. Number returns and its name. But I kind of want the bytecode in there somewhere. I can just do that actually by changing the string here. Gnomic? I don't think I've heard of that one. Edderfoss, how you doing? Gnomic? 1982. Oh my god. Okay. Now. It's one of those. sprint f, we're gonna, it's gonna be, we're gonna put the opcode at the beginning, so it's gonna be $% 0 to x underscore, and then the name. So I dot opcode and then name %s, like that. And then this is we're just gonna $% 0 to x unknown. That's what we're gonna do there. Okay. Then for these, I can remove this. So there's a bunch of instructions that share the same handler, or a bunch of opcodes rather that share the same handler. These are a few of them. I don't need to put that in there then. Because that's going to be easy. It's already in the thing now. Okay. Get rid of that. Get rid of that. Halt 9B. Get rid of that. Get rid of that. Where else? Oh, halt 81. There's a lot of halts. A lot of halts. All right, so now we can go ahead and rerun that script. There it goes. E5 disable sprite, unknown, push word, unknown. Good. Okay. That's a little better. So yeah, B8. Oh, no, that's not what I want to do. I want to come over to here. Where is the debugger? There's the bugger. So B8, handler. B8, push word to stack. Go to. Pushes the inline word to stack. Okay, yeah. Okay, then E3. Yeah, that doesn't. Okay, that does mostly nothing. Okay, so E3. E3. Go there. Okay. I have no idea what this does. Cool. Is this code up here? Bet you that's all code. It is 8275. JSR and RTS. 67. That's that goes up to there. That's a loop. A31B. That's in there. A25B. Oh, that's probably all. Oh yeah. Yeah. Look at all that. Look at all that code. So much code. And presumably none of it has been hit in this in this tape. A lot of code. All right. How am I labeling the jumps? Just an L and then their number, address. Doing fine. That's good to hear. With my brain being a bit fixated on how to do one BRC. Not sure I'm familiar with that. In this Famicom, something about how to get it to read 13 gig of data in one go. What? Logical X, or Logical, how you doing? This is Messin that I'm looking at right here. Messin 2. 1 billion row challenge. Gotcha. Oh, all right. Yeah. Okay, I remember now. Yeah, this is the emulator, Messin 2. There's a 2 at the end of that. Supposed to be 2 at the end of that. This back here, this is Vim. All right, edit label. D01C. Oh, that's a few of them. All right. So what do you do? There's all a word. All right. Edit that. Word 470E. 2 bytes. RAM banks. Load that. Branch minus. Oh, RAM swap stuff. Okay. Bank swapping. Okay. I'm doing okay. I'm resisting the urge to spread some more democracy on stream. Wouldn't be too hard with custom hardware, but I want to be able to do it in Messin 2. Good luck with that. As far as I'm aware, there is no mapper that supports 13 gigabytes of data. As far as I'm aware. Does Messin support that new mapper that's got the Wi-Fi card in it? Yeah, do you know what I'm talking about? Set up a web server just so you can like request like just chunks of the input at a time or something. All right, so this is a how about RAM swap? arguing A, I guess. Branch minus down to there. Okay, so that's a RTS. Edit that to be RTS. And that isn't 104. That... No. I don't want to use those. That's D04E. I'm going to use those. Found that Nest 2 does support that size. Really? I don't know if a mapper that does it either. Should I could chain mappers or something, but currently looking into something into using the data recorder instead. Ooh. Okay. Yeah, I didn't think of that for some reason. Okay. I don't know why I didn't think of that. Yeah, because that's an arbitrary size of data. Yeah. All right, where does this go? Edit that. Label, what did it say it was? D045. A and B. Okay, so these are choosing which bank to go to depending on this guy, if it's positive or negative. For, yeah, if the 16-bit word is positive or negative. If not, compare that. Well, no, hang on, wait. No. If it's negative, returning. Compare it to 50, BCC. What the fuck is BCC again? In the compares, 6 indices. Because I can never remember this. Oop. No. I guess that's over there. That's over there. I want this one. All right. Carry clear. Accumulator is less than memory. Okay, so less than 50, hex 50, we're returning. If it's less than 60, hex 60, we are choosing this guy. Like, what the fuck? Appreciate that. Otherwise, we're going up here. So, okay, so... so this is less than 60. Which carry clear. And this one here, greater than or equal to 60. And less than hex 80. This guy is edit. So greater than hex 50, and less than 60, right? Maybe. Research Dev, how you doing? You recognize me from where? Slash Life, how you doing? Morning. English 1, less than 1. Greetings. I think that's correct. Maybe. Did I used to work at a printing S company? I still work at a print and mail company. Waves furiously. Tamarcus, how you doing? Welcome. I scrolled a little. God, that freaking scroll really, really frustrates me. All right, so we're just edit this. Swap based on arg-a. Inspect high byte of arg-a for for details on bank swapping. I guess, I don't know. Sorry, I'm just waking up in organized life. Fair. That's fair, you know. Just saw a buddy of mine with a mobile phone spook. Hard reset and restore from backup because the phone app would not react to touch input. Oh no. Was that a software issue or was that a hardware issue? So did you have like an on-the-go adapter with a mouse? Because for Android anyway, if you plug a mouse into a phone, the mouse is just that the phone's just like, hey, yeah, I know what this is. Suspect malware. Okay. I see. All right. Wait. So this call. Which one of those? Oh. Okay. So they're. Ooh. This one doesn't do any shifting. This one does some shifting. Okay, so We'll never know exactly. Yeah. Okay, so here, edit that. Shifts before swap. At this, no shift before swap. Okay. Now that we're on which one were we looking at before? 9D? Is that what we're looking at? 9D? Here? Okay, actually, I can just go back, can't I? Yeah, I can. No, we were looking at E3. High ramp swap and work. Which one's the high ramp again? Like what do I have that as? This needs. Hang on. Ah, I'm okay. I'm okay. My eyes watered up a little bit for that. Ugh. A leprechaun's coming from. Oh no! All right. So I don't remember what high RAM versus swap RAM or high work RAM versus work RAM is in this context. Hi. Okay. So. Thank you for the file. Appreciate that. They don't use the same subroutine in both cases. Just different source variable. For what? For this stuff here. These are going to two separate subroutines. One of them does some shifting, but the other one just doesn't. Just writes to the registers directly. These guys here. This one just loads up it loads up, ands it, ors it, and then stores it. Whereas the other one, this guy here, loads it and This isn't shifting. Load and store. Load, store, or load. No loop. Oh yeah, that is. There's a shift right there. Yeah, system's doing a bunch of shifting around. 6 times. Yeah, just based on how it's packed, I guess. I don't know. Yeah, and swap some stuff around. Yeah. Oh yeah. The address is different, right? Yeah. Yeah. So that's what that does. Actually, let me go back to that because I just 4200. The red and 4200. Come on. Thank you. Nope. This one. So the high bank will be 6 to 8K, right? Okay. And then this one. Store it. Oh, so this. What the fuck? Huh? Okay, so we're swapping around some stuff there. Using argument A. Load Y. Wait, hold up. What the wait, what? RG is an address. What, E3, okay. F9. All right, so it's using the like an absolute address in CPU space then. Maybe. Okay, so it's swapping to that bank, and then it's reading from that bank to then swap again. So this is like a dereferenced bank swap? Is that what that is? Like a dereferenced bank swap? Is to get an address pointed to by arg A. First swap is to get pointer page table. Oh. Is using the data at the pointer. What the fuck? The swap program 4710. This guy here. Use the value in A or argay. Negative. Load, stores. So this is just 4710. Directly. Is that stored? Okay, so that's stored here. In case it's not loading anything from that second page. It's just putting that in the argument. It's modifying the low byte of the argument. Yeah, I'm inside the belly of the StudyBox scripting engine. Yep. So yeah, it's just modifying the low byte of the argument and storing 0 in the top byte. It's just setting argay from the value loaded after the first bank swap. Second swap using the data is second swap. Well, no, that second swap doesn't have any. Why the fuck is it swapping? Back to where it was before, something like that? That's possible. Load store. You know what? I think so. So this one loads it from 11 to 10. It stores in 10. And this loads from 10 and stores in 11. So okay, yeah. Yeah, so that's like so would this be current bank then? Uh 47XX RAM registers. RAM. Registers are at 4200 for the mapper. Does a bank swap and returns a value at a specific address in the swap bank? Is that address constant across calls? Doubt it. Double buffering? Yeah, kind of. Kind of. Let's go back and then up here. All right, so this is going to be like the backup then. The backup bank. Because then this... Store... Oh, yep. Okay, so this... this would be like previous bank. Previous bank, current bank. Yeah, so that backs up the current bank, so we can go back to it. Edit this. No, not that one. This one. Edit. So back to original bank. Shit. I can't do it on that one because that's up there. The first swap is to get the correct data for the page with the pointer. Second swap is nope. That's okay. So that's not right at all now. Okay, so using pointer in arg A, swap bank. Just put in okay. Swap bank. Load bytes into arg a. No, arg a. Restore. Using pointer. Then restore urge bank. Active in background banks or subroutine context bank quick load, my thought process. Yeah, something like that. Like a bank to come back from. Or go back to and all that kind of stuff. Yeah. So what do we want to call this opcode? Deref. What do I call this? Load byte. Load. Get byte at arg. How do I? Okay, yeah, keep the handler part in there. All right, edit. Get byte at arg a. That's all right. So that's E3. I want to see what this 9D is as well. Go to location 9D. All right. Tape TM NMI shenanigans. Okay. I mean, sure. All right. Does this have 9D? Bytecode 9D, parameter of 2 arguments, no results. Okay. Arg A and B, yep. Okay. Load that. Sure. I forget what that's used for. Branch equal to there. Oh, is this like the input from the tape? What did I say it was 740. No. Well, that's Are we like waiting for data from the tape? Load that, store it there. Like we have data or something like that. That's not set here anywhere, is it? Long jumps, another long jump. Turn off NMI. Something tape. Oh, that's a loop. Okay. Is this code right here? Is this relevant? Probably not. Table. Okay, so this is gonna be data then. Mark as data. All right. I don't want to go into that one. So this probably starts like some like reading from the tape. Set in NOI seems to wait for NOI or other RQ. Yeah, so this is like tape crap, right? So my guess, because this is the first page, right, is it's setting up some loading for tape stuff, possibly, right? Because there's a jump in here. A round number milestone. Thank you for 64 months, Bridgewater. Appreciate that. It's a good that one's a good number. I like that number. 64.
Another round number milestone. Storage
Is this what's controlling the reading from the tape though? It's possible. So little argument B branch not equal to here. Check for 0, but check for 0. Compare 0. That shit. I don't think they're muted. I heard them. You should have heard them. Maybe it was a little low, but I heard it. I think it might be a little low, honestly, but it's tied to the music volume. Yeah. Argument is argument A the first argument in the stack, or is that the last argument in the stack? I don't know. Either way, both of them are 1. Edifaust, thank you for the 18 months. Appreciate that. Very low, just barely interpretable as words. Okay.
Mine's not quite as round. It's got 2 bits in it. Oh well. Regardless, thanks to the Bridgewater for my sub gift. Laughing face.
You heard that one though, yeah? The music was not doing anything. Thanks. Okay, yeah, so this is something tape. Or let's not do it like that. Let's do like something tape. $9D. Not equal or a B, jump 0. Jump 0. Where does that go? Does that take something off the stack for that? C0. Jump if 0. Yep. Here. Set code pointer to inline argument. That's not inline. Argument A is not inline. Digging through every single opcode. Yes. Jim Mega, how you doing? And for this, I'm using the script as a basis, or as a guide, I guess, to see how things may work. Yeah. I haven't watched it yet, so I haven't actually watched any of the new season yet. not 0, not 0. Wait, what the huh? Wait a minute. What is this? What? Why is that comment like that on all of them? That doesn't look right. Edit with label. What? So it's going to duplicated. It's maybe that comment duplication again? Possibly. There's the fall shown on Thursday, so except for what they did to protect, that's good. Take into account both sides, the scripts, what they do using those opcodes, and the opcode implementations themselves. Yes. Yes. Number Joker, how you doing? Yeah, we're not spreading democracy right now. I'm gonna be doing that after stream, certainly. So I'm gonna take these out because those. I don't think these are correct. Branch should return 1. Stores that in A? Oh my god. Okay, well. Anyway, we're on this one. So load up A. Branch not equal, not 0. It does do the code pointer shit. No. That's what this crap is. Fuck. That was right. Can I control Z that? No, I can't. Okay. But it's not inline though. Hang on. Clear carry, load code pointer, add carry to. It is. Add carry to code pointer, branch carry clear. So that is actually correct. Edit that. Yeah. Okay. So these guys, BF, C0, and 8.4, have an inline. What's the null terminated count on words? Count on words. Just 2. Okay, just 2. All right. How's an argument given inline in 6502? So this is not 6502. I'm actually diving through, kind of, sort of. For 6502, something like this, that's inline. Or absolute. Or, I'm sorry, the immediate. It's immediate inline for 6502. That's the terminology there. But yeah, so what I'm looking at isn't assembly, really. It's a script. All right, so BF op count, so that's the second byte. BF okay. C0. That one has 2. 84. Okay, there it goes. First place, Pete. How you doing? Welcome. Yeah. So now it's showing it inline. Okay. Jump 0, jump absolute. Okay. called get by okay. What is that 0 doing there? Like, what is this doing? Inline arguments are just stored in the common location. The term inline referring to the script, not necessarily. Yes, yeah. So referring to the script itself. The script, by the way, looks looks like that's unpacked English 1 script data 0. So this is the script I'm actually looking at here. This is the entirety of it, right? So this is the whole script that I'm looking at currently. This is stored on the tape. This is what is executed in the engine on the StudyBox. Yeah. And by inline, I mean data in this sequence of bytes, right? Or rather, sequence of bytes after the given opcode, right? So that jump absolute is an 84. So that's this guy here, right? And you can see the address is 6007, and that address is right there in line. It's right after that 84. And the bytes are swapped because little endian. Yeah, the entire script is only 30 bytes long. This one's small. This one's tiny. There are some larger ones, like the next one, I think, is a larger one. Can you not? The next one's a little bit larger. You can see the text unit 1 in there. LSL on all those. Yeah, so some of them are a little bit bigger. This one's the first one's only 30 bytes. Next one's 206. One after that's a little more than a K. Yeah. Can I get a quick rundown on what's going on? Yeah, sure. So I was trying to plug that, so I'll have to unplug it. So I am reverse engineering this thing. It is a tape drive for the Famicom. So programs come on tape, and everything on that program is on this tape. All of the images, all of the audio, all of the code, everything is on the tape. And it's split into different packets, kind of. The packet type we're looking at right now is a script packet. There's also CHR data, which is just the image data. And then there's the tiles themselves. And then there's the name table data, which is the arrangement of the tiles on screen. Like lookup tables, kind of. Well, not really lookup tables, more like data tables. I'm not really worrying about those too much right now. But I'm looking at the script that tells the engine what to do and when, kind of, and how to load stuff and whatnot. Like this one here, we're disabling some sprites. We're doing something with the tape, pushing a word and getting arguments and crap. I'm not exactly sure what this is doing. My assumption is, because this is the first script, my assumption is it's setting up loading the rest of the scripts and the tape. Hacking the matrix, yeah. Reverse engineering the bytecode interpreter of the StudyBox, right? And as for what this was used for in its original run when it was sold, the main thing that I see it used for, because this is the easiest stuff to find for it, is teaching English, like English workbook stuff, and that's actually what we're going through here. You can see this is the English 1 tape. So yeah, and the reason it's on cassette tape is because one of the channels is the data that we're looking at here, and the other channel is recorded audio. Anthony, how you doing? Welcome. How's everyone doing? Thanks for the raid, appreciate that. Secret Val, how you doing? So yeah, I just explained it, but I'll explain it again. So we are looking at the script data for this thing. It's a tape drive for the Famicom for teaching English to Japanese students. But yeah, so there's like scripts that are on this tape, and we're going through those scripts and trying to figure out how they kind of work. And yeah, looking at the bytecodes of the scripts and going into the corresponding handlers in the bytecode engine to figure out what it's really doing. Yeah, scripts on tape. Yeah, so actually, let me open up one of these tapes, one of the raw waves. There we go. So let's open this up. Come on, there it is, and bring in this one. So this is the tape that I'm currently looking at. So you can see the top looks like standard audio because it is standard audio. It's recorded audio. The bottom is where all the data is. And if I switch this to this guy here, yeah, that looks a bit more recognizable as data, right? Can I zoom in? There it goes. So what we're looking at is some really early stuff. Probably some of this. I don't know if this is all of it, or if that's part of another script as well as the second script is possible. But yeah. So down here is the script data, and then up top is the audio stuff. So let me split. I'm gonna mute the bottom one because I don't want to hear that. I'm gonna pause this real quick. And can I just hit right there? You can hear that, right?
Enjoy English. 1号この号では自分の名前が言えるようになるのよ。さあ、ユニット1からスタート。
Good. Yeah, stereo channels used for data and audio. Yes, exactly. Been inconsistent lately, haven't we all? Yeah. But yeah, so we're trying to figure out how this ticks, essentially. Oh yeah, and the code in this thing, oh my god, there's so much jank. So much jank. It's unbelievable. Like I thought the code that I wrote was bad until I saw this code. So whenever you're writing code and you look at it and go, oh, this is disgusting, how I could never make it. No, you're wrong, number one, because this is a commercial product that was released. And some of this code that's in here is disgusting. Disgusting code. No matter how bad your code is, it's better than what's on this thing. Burned into the chips of this. But yeah, so we also have this running in the emulator too. So I'm gonna, if you can hear it. Oh, I've got it really low. Give me a second. Let me turn that up a little bit. Audio. Let's turn that up to 70 something. There it is.
Enjoy English.
Watch me.
1号この号では自分の名前が言えるようになるのよ。さあ、ユニット1からスタート。
Yeah, can't release this. You clearly haven't seen Game Codex, right? It's so bad. It's so bad. Like, so when we originally got this working in an emulator, there was some glitchiness with some of the sprites. Like, I'll let it play through a little bit. So you'll see some sprite movement. Let me actually turn it down just. I'll turn it down over here. Turn it down just a tad. So there's some like larger meta sprites that are moving on the screen. I'm gonna open up the sprite viewer so we can see them a little bit better here. Sprite RAM. Yeah, sprite RAM's fine. And now so it's loading data from the tape right now. Well, emulated from the tape anyway. During that, but did you see that little flash of crap on the screen? It was very quick. I don't know if the stream picked it up, but that's part of it. Number one. But so yeah, so you see these sprites here, these meta sprites. The code to handle these meta sprites and animating these meta sprites is terrible and slow. It's so slow that sometimes it doesn't finish in time, an entire sprite will be missing. So I don't think it's the next one. Is it the next screen? For some reasons, the code of the game I'm working on has some temp code that's, if this is a specific asset with a given name, then do something specific for this. Handle this thing specifically, you know. Oh, it is good. All right, so I'm going to slow this down a little bit once it starts showing here. Oh, it's behind. It's desynced. Oh no.
Hello.
Oh, there it goes. Okay, so I'm gonna slow this way down. The audio is gonna be really jank because it doesn't the emulator doesn't handle slowing down the audio very well.
Hello.
I'm gonna mute that actually. I'm gonna mute it so it doesn't sound like he's having a stroke. So currently we only have one sprite that's animated here, right? In a second here, we're going to get a second sprite. This is brother. And this is running at quarter speed. But once his brother starts coming in, and you see when it animates them both at the same time for whatever reason. Because they don't need to animate on the same frame, but they do. But sometimes it's not fast enough for updating the second sprite, so the second sprite just won't display at all. It just won't be there. Come on, where is he? Speed, normal. Let's get him in. Let's get him in there. There he is. Okay. So now you see him flash? Yeah, there's some frames where he's just not there. So move him over there like that. What is it? F8? F8. All right, so I'm going to advance one frame at a time. And the next update frame. So he animated. One of them animated. F8. He's gone now. He's dead. And then the next frame, he pops back in his second frame of animation. So terrible. Because so what's happening with this is taking all those individual sprites of the meta sprite, moving them off screen, then updating some variables. I think the tile IDs, right? So the actual tiles in here. And then after it updates them all off screen, it moves them back on screen, which is incredibly inefficient. Yeah, and right. Just to be clear, this is not an emulator issue. We thought it was originally. But then I got some tapes. I took the audio originally and recorded it onto like new tapes. But now I've got original tapes. This is on hardware too. Second figure is magic. I don't know about that. But yeah, that happens on hardware. So the emulator is correct. This is so jank. So jank. And part of it, I'm convinced, is this script engine and how it handles the animating. Because I'm pretty sure it animates while interpreting the script, which is, oh my god, slow. versus native code, right? Native assembly. But yeah, so we're digging through this, trying to untangle a bunch of it, with an eventual end goal of being able to make my own tapes, specifically not using any exploit. We've already done that. It's trivial to dump a bunch of assembly or compiled or assembled rather ROM code into like some random data chunk, right? And then with the script, it's like what, 7 bytes, I think? 7 bytes of a script, and you've already got an arbitrary code execution that jumps completely out of the engine and just does its own thing. I haven't gotten that working on hardware yet, for a few reasons, but yeah. Some places they even end up with half a sprite on screen for some frames. Yeah, it's hilarious. We had multiple choices for how to get control of the system. Yeah. So I do want to be able to write a program as intended for the machine first, right? Well, maybe not first, but I do want to be able to write a program as intended for the system, as well as just exploiting the thing out the nose. I do want to do that too. Yeah, so because like one thing I kind of want to do eventually is like be able to like give a talk on this, right? And my journey reverse engineering it and how it all works and all that kind of stuff. But I want like the PowerPoint to be on a tape on this. Where I pop in my presentation and start it up on hardware. No. How does the script engine handle values and variables in the script on the virtual side? Registers, push down automation. It is stack based. It is a 16-bit stack based engine that passes around strings, which are not necessarily English strings, because Japanese company and all. I had to watch that dead time. So I've got some ways to I've got some work to do before I can get to that point. It is something that I would want to do though, but I'll talk a presentation about the StudyBox on the StudyBox, right? Yeah, so I'd love to do something on that as well as something on the titler, but yeah, I've got more work on the titler to do. Yeah, for that, I'd really want to figure out how the handwriting input kind of works and really dig into that. But that one's a long ways away. I haven't even gotten close to any of that stuff. And maybe even a bit like on the hardware itself and how it synchronizes stuff and whatnot and how that all works. But but again, I've got a long ways to go on that one. Much longer than StudyBox stuff. Because we've been working on StudyBox stuff for how many years now? 4 years probably. I don't know. It's been a while. It's been a long while. But anyway. So where were we? Oh yeah, okay, so this has to... So this... 618. I'm curious like where this stuff is. Like where this script is located while it's being run, There's a guy on YouTube who made some reverse engineering progress on the SNES, I believe. Got the Nintendo gave me to watch, third-party cloned, etc. Oh, all right. Nice. A presentation on the StudyBox about the StudyBox. Yeah, that's the proper English, yeah. So first expectation a bit, since the on can also be interpreted as about. Or just a presentation on the StudyBox. Leave out the second part of it. Just, yeah, it's a StudyBox presentation. Don't worry about it. Yeah. Oh, you think I'm going for the 8-bit aesthetic with this presentation? No, I'm using an 8-bit machine for this presentation. This isn't an aesthetic. It's reality. Been a while, especially if you remember the frogs. God, right? The frogs. Yeah, it's been a few years. We've been doing this stuff for a few years. See, let me actually put a breakpoint on this disable sprite opcode because that's the first one in the script, right? So when we hit that, we'll know exactly where we are. E5D, E5 disable sprite, go to breakpoint. Excuse me. All right, then we're going to come over to here. Let's actually get rid of this guy because we don't need that anymore. Game, reload. Okay. Controller. Where's my controller? There's my controller. Page 1. The physics-defying ball. Yeah, that. What are those other numbers in the decode output? The 30 and the 96? I don't know yet. I have no idea. All right. So we hit it. So this script executes before anything's even drawn. So it's going to be setting up a bunch of stuff then. So we're going to have a look at the memory viewer first. We don't want the palette RAM. We don't care about that. Reset that. And we're going to have a look. Actually, let's code pointer 6004. That's where we are right now. Okay. All right. Let's get down there. 6,004. So we're right there. So that jump absolute to 6,007 goes to the B8, which is push word. Okay. So that's a loop then. Let's can we I want to be able to put labels into this. Output position. Okay. No, that's integer. Arg start. Okay. So for that, sucker pinch. Reverse emulating the nest to give it a super. I've seen that one. Yep. Small with tape stuff in it. That's a wait for audio to be done. Maybe. Probably. Yeah. All right. So how do I want to do this? Vice join. Iron. Word val. Okay. I'd have to go through and see. I'd have to reorganize this a little bit. I don't know him personally, no, but I've seen some of his videos. Yeah. Interstellar Pop there. How you doing? Welcome. But yeah, so this is almost certainly going to be like a wait for the rest of the stuff to finish. Script data page 00. Put it there. So I can go over here and do that. There it goes. So yeah, that's what did I say right here. How do I want to define labels in this? Label 6007. I don't like that, but I mean, I could just like indent the rest of it though. I still don't like that, but whatever. So yeah, so that's a loop. Jump 0, so I'm gonna guess that's gonna be right there. 601A. 601A is there. 83, yes. Okay, so this is the break out of the loop. 601A, right there. Then 2 unknowns and a halt. Okay. So yeah, so that's a loop of some sort, obviously. 44FA and 44F9. Oh, those, do I have those defined as bytes somewhere? 4434, no. 44FA. What is at that right now? 44FA. FA right there. So it's part of an array. Huh. Okay. So I want to like step through this now. 83. So let's. Something tape. Yeah, let's step to that tape one then. So what was that again? 9D. Go to. Put a breakpoint there. Okay. What is that? Read? Write or something like that? What is red? Red's a write. Is it just writing more data then? Is it continuing on with that? 96 is hex 60, so if the code starts at 6,000, there are 2 bytes. The address of the script is loaded up. Maybe. Ooh. Okay. Yeah. All right. I see. I see where that's going. Yeah. That'd be the address of the the end of the script. Like so 30 bytes. Oh. That's like they can do the spec for UI system and finding that they managed to botch keyboard input focus handling. All right. Well, let's go back here. Is that the next script though? So 1010. Okay. No, that is not the next script. That's something else. Pika Dutch. Hello, how you doing? Welcome. Okay, so that's not the next script. What is that then? Is that just something else in here? Like CHR data, maybe? I really should have, I don't know, organized this a little better. No, that's just the control stuff. All right. Load work RAM. Data. Length 30. Okay, so this load work RAM and then the data, this right here, that is our first script. Mark data and script, delay, mark data and delay, delay, and delay. There's a bunch of delays. Okay. Page 1. Length 128. That's data. That's the second script, though. That's not what we're looking at. What is this other data it's reading? Is it... I mean, it could just be... Well, I don't know. Print stuff in the fact that we're not in fact touch. They're not sorted by appearance on tape, are they? Well, kind of, sorta. They are. I forget exactly what all those numbers are. Where's my unpacking? Oh God, where was that? It's over here. Yeah, let me command StudyBox. That's not what I wanted. SB util. This is what I wanted. Unpack processing. Okay. Press all make there. StudyBox read file. Oh, damn it. Going there. There's a read. Read file. Okay, does the read tape. Oh, it just reads the entire thing. Oh my God. All right. It reads it. Okay. Sure. I'd probably do this differently now, but whatever. That's fine. Equal, yeah, identifier, okay. Length version, decode the chunks, page, missing page chunks. Missing audio, unpack audio. Unpack page, this is what I want here. Unpack page. Identify page, update on page, okay, decode, TP, what the fuck is TP? It's a page, okay, it's cool. Packets? No. Decoder. Returns packet next page, next state, and error if any. Map of state. Each state is a map of types. Huh? Oh, because okay, yeah, I think I know why. All right. Main decode loop here. Okay. Packets decode bulk data. Okay, defined packets. State packet. DF. What the fuck is DF? Right. Okay. Decode delay. Decode. SB export. Export. That's what I want. Pages. Okay. For the page index and the page in pages. Page index. Okay. Right. So that's not what I wanted. So this page right here is the actual page that you select, I think, on like the main menu, right? And then let's see, where's the script stuff? Page index and data start ID. That's what that is. Data start ID. Okay, so that's the packet number. Or something. I guess. Yeah, so so they're sequential in that sense. Yeah. But they're not, well, can I... Can I rename this stuff? Trying to think now. For f in chr data underscore star dot chur do echo cut echo f cut. How the hell does cut work? All these bytes, all these characters, delimiters. B from 1, 2, 3, 4, 5, 6, 7. Need 8. 8 to... What's that, 20? Oh, almost! 19. Now then, how do I know how? Haha! Okay. 9. Move file to that. Did that work? It did. Beautiful. Okay. So we're going to do the same thing for the name table stuff. NT data. That's not going to be that though. These numbers are going to be different now. Hang on. NT dat. That was close. 18. Much closer. Okay. And now we want the script data. Can you not? God. Okay. 22. Oh, perfect. And then we're gonna add some of that one. Beautiful. Move. Thank you for the follow, by the way. Appreciate that. F2. There we go. In page underscore star dot text. B 5 to 7. Nope. 6 to 7. There it goes. Move this to page that dot text. Didn't sort it how I wanted to sort it, but whatever. If you have the rename tool, just rename it as... Well, too late. Thank you for the follows, by the way. I appreciate that. Got the answer? Yeah, name table. Yep. Specifically, the data that is... this stuff. So the data here. Not to be confused with the tile data. Not this. Not this, but this. How it's laid out and organized. Yeah. Okay, so let's have a look at this here. First, let's see how large it is. Okay, I forgot that I'm in a different terminal. Excuse me. $10.78. Okay. Let's just dump the whole thing. Okay, we're not gonna dump the whole thing. We're gonna dump just the top of it. All right, so that's not the data we're reading then. What is the data we're reading? There's page 00 text. Wait a minute. Okay, yeah, so this is the script we're reading through right now. Maybe it's this. Or is that... No, that's... I think this is the actual data for the, for this here. 56. Maybe? I don't know. I don't know. Anyway, what do we have a breakpoint set to? Something tape. Okay, so I don't want... That's before... Okay, so that's before all that. So that's only going to happen once. Let's go down to 83 then. Let's set a breakpoint at that one. 80... I don't have one for 83? Is it sharing another one? D33A. Okay, go to D33A. Okay. Handle Ray 3, there it is. Thank you for the file, appreciate that. Okay, so I don't even think we've had a look at this one yet. The only reason I have this comment here is just to separate from this tape shenanigans crap. Alright, so what the hell is this doing then? Load one, store it there, jump to there. Huh? What? Oh, so this is D329. That's what that is. Edit label. Label D329. Up here. Let's store it. Okay, load EE. And it, compare it. Branch not equal. B329. This is a wait loop. By E, where is this used? In a bunch of places. Okay. Tape stuff. Okay. So is this waiting for like the end of the tape data or something? Start it. Load D4. C8. Click on, how you doing? And Blocky Headman, how you doing? Out of curiosity, what languages do you use, and how do you learn ASM? I learned assembly through brute force, but the languages that I use, I guess, like for work, one of them is PLB, which is a terrible language. It's the worst COBOL. And Golang. Those are the main languages that I use. But I dabble in a bunch. Yeah, assembly and all that kind of stuff. Other languages I know are PHP, Perl, Python, a little bit of C, C++, some C#, a little bit of Bash. Others that I know I'm forgetting, and a little bit of COBOL. I don't remember the others off the top of my head. Oh. Yeah, basically whatever fits the task at hand. Yeah, more or less, yeah. Pretty much. I actually recently used some C# at work because I wanted to write a quick and dirty little user interface to interface with a command line tool that is garbage. So that I use C# for that because WinForms is really simple for me to do. So it's learning assembly by brute force. Yeah, that's the short of it anyway. Yeah, basically. Yeah, I wanted to figure out how games work so I could reverse engineer them to use exploits to find exploits to use in tool assisted speedruns. I got distracted, and I'm still just reverse engineering stuff now. What is that video? I'm not watching that. Whatever. Ramazan, how you doing? Am I saying that right? Welcome. By account name. All right, Jesus. D4 to EE. So okay, so this is some sort of like a status byte for tape stuff. It's gotta be, right? And to compare it there. Wait on E. No. Waits for byte EE to equal F0. Apparently, I have EE down as, and I quote, huh? So, I'm guessing it's something to do with the tape status. That's what I'm gonna guess, without digging into it too hard. I don't know. 740 is basically a command for NMI and then uses by E as a response is ready kind of thing. That's yeah. So this is we're obviously waiting for something in by EE, right? Hang on. Let's look at all the stores. Okay, so this one sets it. Whatever this one's doing. Label 8C8F. This guy. Well, that's even a loop. Okay. Load EE, and it compare it, branch not equal. This is the opposite. So this is waiting for the low nibble to be 3. What? And then this is what sets the high nibble to F. Looking at handle area 3 too. Is that where we started? Is that where we got into this one? Handle area 3? Yes, it is. Okay. I was confused there for a second. Clears the low, keep the high. No, I'm sorry. Yeah, clears the low. That's an and. That's not an or whatever. Yeah, it's clears the low. Yeah. Well, wait for byte EE low nibble to equal. My God, equal 3. Equal 3. Then clear the low nibble. When it does, keeping the high nibble intact. What is this? Is this code? That's code. Oh, you bastard! Okay, there's more of it. All right. What is this doing? Hang on. Let me label 8C9E. What are you doing now? Same thing but with 4. Wait for 4. Okay. What do we have on D4? The opcode D4? Temp storage. Oh, the byte D4. That sounds about right, honestly. Labels. Byte D4. Find occurrences. Oh yeah, that's gonna be some kind of temp storage. Probably for the byte though. For the tape. So this is like load it, compare. Branch equal to 9.7. That's here. What is this? Edit label. Label F18E. Where's that going? Okay. AES here. Looks like E is only ever 0 to set to the value in D4. Yeah. Yeah, this is in some tape chaining again stuff. Not directly from that label, though. No. F025. Sort of uses as temporary storage by various tape data handling routines. Yes. Yeah. Compare bits 0 and 1 to be set for whatever reason, then do the same for bit 2. Clear the bits in every turn. What do you mean by that? So yeah, D4 is some sort of like tape temporary variable thing. All right, let's get back to where we were. $8 Canadian. Okay, yeah, we're here. Edit this. Same as L8C8F E. Wait for 3. Only waiting for the value of 4. Value 4. Yeah, so we got in there from there. Okay. Oh, and that just returns to the script after that. Okay, so let's edit this like that. Okay. So this is some sort of tape weight, right? A3. Waits for tape condition. Test the variable first, so probably that value is handled somewhere else. I'm swinging NMI. No, it wouldn't be NMI, it'd be an IRQ if anything. If it's waiting on E, it's waiting on something from the tape. Alright, so waiting for tape data then. Waiting for tape data. Yeah. Waits. Using byte E. Which one is for on the StudyBox? Yes. So NMI is for all the PPU stuff. So the any cartridge can't really interact directly with that. They can't trigger it anyway. They can trigger IRQs though. So that's what the cartridge is used for, like scanline counters and the like. And we're using it here for tape data being ready, essentially. So when an IRQ fires, that means that the tape circuitry in the StudyBox has data available to read. Or at least the hardware is ready for the next poll. I don't know, not necessarily data from the tape, I guess, but yeah. Where's D4 set? All over the place. So here's one of them. Loads the data byte from RAM. This is something that's read off of the tape. The one here, same thing. Comparing it to previous values, probably. More storing, loading it and ending it and doing some rotation stuff, and then storing it back. That's this one here. Let's put labels on these too. Byte 471 44 FF, really? FF? For FF. Add this label. This guy is going to be byte 44. Nope. 44 E4. Three. Label F106. That's not right. Edit that label. That's not 3. That's an F. Same thing there. So these are some older labels, I think, from Messin 1. When it created auto labels. These are in ROM space, not CPU space. Which is why they start with a 3 and 7 F. Edit. But I want these in CPU space. I'm not going through all those right now. Yeah. So okay, so that's some sort of tape weight. Fine. 83. E8. What is that one? Handler. E8. Go there. That's literally the next one. All right. All right, turn off NMI, set up NMI. All right, let's have a look at all this code. Well, that's... Nope, that's data. All right. I should have known. It's all Fs. Not really data, actually. Technically, it's unknown, I guess. But whatever. We're saying it's data because whatever. It's fine. This guy's F, not 3. All right. Set up NMI. So this goes to right at the NMI jump to RAM. So raise jump ED. Okay, yeah. ED00. Okay. Sort of my initial. It's a long jump because it's not an RTS. Oh, not an JSR. God damn it. Let me put these down here while I'm here. F870. Thank you for the follow, by the way. Appreciate that. Edit. Label. EC E8. Some of these aren't decoded yet. Yep. All right. So yeah, so that's up the NMI. A long jump for that. Okay. EF. What the hell? Byte EF. No, let's occurrences. Okay. Load it, store it there. Load that, store it there. Okay. Load, add that to A. Store that, load that, and it with 3F. Store it in F2. What? A long jump, okay. E7. No. EE32. Oh, let's forget what this does. 4016. Controller stuff. That's no. What the? This is weird controller stuff. What the hell? That's a weird strobe. All right. Push A, set carry, load A, subtract, branch not equal. Pull A. So this is a division by something then, right? No. Well, I subtract carry, branch not equal. Wait. No, what the that's just a delay loop. Using subtract? Oh yeah, I didn't mean loop. Yeah, no, RTS, sorry. Label EE71. SBC delay loop. Okay, well, I want that down there like that. All right, so loading 7, and then so what the hang on. Hex 7. Octal. Not octal, hex. And it with 4. It's 4. This is a weird strobe here. That's a really weird strobe. What is it doing here? Like, is this that weird ass? So there's the test screen, right? It's got like a touch screen nonsense thing on it, right? that doesn't react to the drawing tablet, doesn't react to the touchpad on the titler, which I wouldn't expect that one to, because that uses RQs on its own, and it is read completely differently. Could the what else? Oh. Yeah, that's a really weird strobe. I don't know. Maybe there's some specific peripheral that they had planned and never released. I don't know. Okay, so starting all that. Load 8. Where is this used? Minus 68. This is the RTS. This guy is a loop. Also, that's not 2, that is E. E. Loop. And this one, edit. E. Pull a decrement Y. RTS. It's not reading from this shit at all. It's just writing. It's just strobing it a bunch. I was looking at that for the tape recorder. Is this like a save data routine to the data recorder? Is that what this is? It's not quite the same, but on the tape recorder, bit 4 being 0 disables read, bit 1 is data output, or 416. Okay. 416 right. When 0 force audio read back, always read as binary 0. Okay. 1-bit DAC audio to cassette. The audio that you can records. Okay. From the cassette, so it's never reading this. At least not in this routine. So yeah, this is some data recorder shit then, isn't it? Yeah. I'm just looking at it before streaming, no worries. Edit label. Okay, label E7442. Possible data recorder long jump. Got the rest of them as JMP as well. I'll keep it as JMP. It's fine. All right. What does it actually? Hang on. What does it use to write? Push A. Pull A. Decrement. Yeah. Okay. Data in A. Byte C4. How often is that used? No, that's not what I wanted. How often is that used? Okay. Excuse? RTS. Sure. Sure, fine, whatever. Load store. EF sounds familiar. Not that familiar, I guess. Anyway, store that there, store that at that array, load that, store it there. There's that byte EE. Let A store it there, F3, and turn on NMI long jump. Okay, turn off NMI. Set up a new NMI, ED00. Maybe some data recorder nonsense. What is at ED00? Let me just ED00. That's not 3. That's F. So it's very bare bones. What does this do? That's tape stuff. Get my tape stuff. Okay. So it sets up the tape reading NMI. Yeah, I'm not sure what the other shenanigans really are. There's some shuffling of some stuff. I have some bytes that I don't know yet. All right, so we're just going to call that setup tape NMI. That was a E8. E8. Okay. I guess for like loading the rest of the data then, because that would make sense. So you set up the NMI to be like, hey, we're ready to load the rest of the data now, right? And then it halts, waiting for that to finish, And presumably when that finishes, presumably when that finishes, this script is done now. Standard Point, how you doing? Welcome. Go over here. Script the code. This is going to be tape. Wait, set up tape NMI. So there's a 1 there. Was this ever like used, by the way? I don't know if this was ever used. Maybe it's something I'm missing entirely. So that tape NMI thing, does that actually the tape weight, does that use inline? Handler 83. No. Then what the hell is this 1 doing? That's the argument right there. What is it doing with it, though? No worries, Marcus. No worries. All right, I don't know what it's doing with that. So who knows? I don't know. All right, so what about the second page now? Let's let's unpack English. No, ls scripts. That. For F in unpacked English. Yes. Star. Do. Excuse you. Echo F first. Good. All right, so for that, we're going to go run script decode that, and then the output into scripts. Base name? Maybe? Yes, it is. Okay. Script data pages, whatever. Okay. Undo all that. That one. E. Does the bytecode interpreter do anything in particular with bytes that are not known opcodes in the instruction stream? Yeah, that would drop it on the stack then, wouldn't it? I haven't looked at the actual decoder in assembly yet. I probably should look at that, but I thought that the keyboard and mouse event bits in this book were better thought out than the various Windows event bits, but it's the other way around. Oh no! Keyboard stuff is garbage. Windows event bits actually map through as well semantics. Reverse a position that held for more than a decade now. Oh no! Alright, so we're gonna have a look at the second script. Sign divide. What? Just immediately into a sign divide? Is there anything on the stack? Huh? What is that? CE? Go to. It uses a bunch of arguments. Okay. It's the first instruction. We're already there. Okay. No. It hasn't happened yet. So where did that animation data come from? Wait a minute. Hold up. Where the what? Huh? Wait a minute. How is it? What? Thank you, I appreciate that. It's a value that happens to match an opcode. I don't know about that. Swing tape. So that was after the... Okay. It loads it up. And now... Huh? Oh, there's an underscore in there. This previous scripts are linked to the first byte, and this is and this was the first byte is linked to CE. Oh. .665A. Where the hell? Okay, let's have a look at the hex jump for that guy. Page 00. No, page 1. Oh, hex dump. C page 01003 less CE60. Oh, wait a minute. What? 02E6. Oh, 60 is 96. Duh. Hex versus decimal. Woo! This is Pony. How you doing? Welcome. Where actually are we in all this? Hang on. C6002. Where the hell is that? All right. Can we see that in here somewhere? B66, BD. Where's CE? Doesn't right? Yeah. Previous one had 01600 is loaded at 6002. No. Can I search first? Maybe. Search. Yeah. Okay. CE6002. Really? We're way up in code. So this isn't even loaded. We're looking at a different script. Did I already get overridden by something else? Almost certainly. Almost certainly. Hang on. Okay. ls star scripts data dot dat. Oh, fuck, I keep. Page 02 03 5A66. That's not executed. Burger Wheel, how you doing? How much caffeine do you drink a day, would you say? About a cup of coffee. First of all, initial interpreters are the initial interpreter stack pointer. That's what it's looking like, yeah. That's what it's looking like. Like the entry point. Yeah, so this is the data we're looking at now, which is why that breakpoint didn't trigger before, because it wasn't script data yet. Typically corresponds to the end of the loaded data. Yeah, okay. So let's go back over to here. Stack start equals raw input 0 to 1. That's not going to work like that, is it? I think the entry point is fixed at 4 or 6 or something. Mm-hmm. Have I used SDCC to make nest ROMs? SDCC? I'm not familiar with that. So, no. $sign. Actually, let me just I'll do it this way instead. Stack start at $sign sent 02x% 02x raw input 1, and then raw input 0. Oh, that needs to go to out. That's not what I wanted. Okay. Yeah, stack start 0. All right. Yeah. And then for this guy, stack start 665A. Was that the one we're looking at? Page 2. Yeah, 665A. That's a ways away. That's in a different memory bank entirely. Yeah, there's the start of it. All right. Binary letting you 16. Just do it yourself. I did it myself. It's fine. Small device C compiler. No. I write assembly directly. We're talking about optimizing C standard compilers with the targets Intel MCS51 based microprocessors. No. No. NES is 6502, not x86. Facing for Motorola. Oh, it does target Z80. Okay. Product. Oh, okay, it does do the 6502. But yeah, I don't really have any interest in writing higher level languages for the NES. Mainly because a lot of the work I'm doing on it is reverse engineering. So like, why? Not a lot of this stuff was written with a higher level language. Ironically, this might have been. But yeah, so that's not really like what I'm going for with my NES dev stuff. Yeah. Yeah, my goals aren't to like get a game done quickly and easily on the NES, right? My goals are more of how would I do a thing on the NES, right? Like how would I implement this? How would I implement that? And I enjoy that a lot, you know? How would I implement this in assembly where I have direct control over the hardware, right? Without the overhead of C and a higher level language and wondering what the compiler will do with my code, you know? I don't want any of that. That's not what I'm looking. That's not a part of my goals for my projects on the NES. All right. Well then, so let's go over here and put a breakpoint on E6. Let's start there. Not how to do it quick, but how to do it correct. Or wrong enough that it has interesting results. So I'm not picky. E6. Let's go there and drop a breakpoint. I wonder if you can write memory-safe NES games in Go. I doubt it, but if you manage that, let me know. I'd be interested to see. Get rid of all those. Could have remembered those before. All right, then we're gonna come over to here, and then we're gonna game reload, and then hit A. Ah. Keybind, how you doing? I'm not completely sure I can write memory safe anything in Go. Thank you for the raid. How you guys doing? Welcome, welcome. Trying to do a good TCP multiplexer with Go, and it's rough. Okay. All right. I haven't tried that. With a custom parser. Oh, my goodness. Fun. Is that what you're doing on stream? Was that what's happening? Right. We're doing good. Just dropping off some nurse for daycare. Because of course there's hard but fun. There you go. Well, welcome. So for everyone just joining, we are going through some took long enough together. God, we're going through some reverse engineering of this thing. It is a tape drive for the Famicom, used for teaching English and math and science and crap. It's got, I think I still have it open. I do. The tape is stereo. Audio is on one end, and on the other channel is data. We're looking through some of the data on the data track. So it's got its own domain-specific language that's interpreted in assembly on this thing. So we're going through those scripts and seeing how they work, how they tick. Yeah. Shouldn't take more than 5 minutes to reverse engineer that. You'd be surprised. Chat, how you doing? Yeah, so much of this code is jank as hell. It's so jank. Yeah. So some of this code here, like this stuff here is Go, but it's like not really decompiling or disassembling. I get decoding the scripts. Yeah. Yeah. Archaeology. Yeah. Software archaeology. That's Unreal. Am I saying that right? How you doing? I do that a lot at work too. A lot of the programs at work are 30 plus years old, written in PLB, which is a worse COBOL. There's the Go. That's what I came. Thank you. Appreciate that. Saw the Golang tag. Yeah. Yeah, so a lot of the stuff I do on stream is either Go, 6502 assembly, or both. A bit of both. COBOL minus, yeah. Sometimes that. Yes, I use Go for a lot of the tools, a lot of my tooling for Nest Dev stuff. Yeah, like for instance, right now I'm using that to unpack the data that's on the tape and start to decode the scripts and whatnot. But for like assembling a ROM or putting a ROM together, I have a bunch of utilities to do a bunch of image conversion things and font conversion stuff to get it into correct formats and all that kind of stuff to use it on the NES. This only might not be too far off the truth, honestly. Judging by the results so far, fairly rudimentary. Yeah, it's rudimentary. Just release a new tape for it at the end. That's one of the goals, honestly. That's part of it. Like being able, so understanding what the script does to be able to make my own, basically. Yeah. How do you know how to decode the format? Do you reverse engineer the format? Yes, we've done a lot of work for reverse engineering this thing. Bridgewater, Sour, and myself. Sour is the one that maintains this emulator. Bridgewater's in chat somewhere. We did a bunch of work getting this emulated in the first place. So this is emulated in like 2 emulators, I think. Messin being one of them, and I honestly forget the other one. I don't remember which one that one is. There he is. He's done a lot of the figuring out of the communication with the tape itself and the opcodes for that. And a lot of the initial work on the scripting engine as well. So I'm using his notes for a lot of reference and looking things up. Like he found the lookup table for all of the handlers and lookup table for all the parameter control stuff, like how many arguments each opcode has, if it has any return results, that kind of thing. So that's what this over here is. And then this over here is more specific to the mapper itself, not necessarily firmware, but the hardware of the thing. The registers, what they do, how much RAM it has, and how to swap the RAM and all that kind of crap. And I did a lot of the hardware verification for this. So I've got a ROM dumper somewhere. It's packed up somewhere. So I verified how much RAM this thing has. It's a lot. And I have also done some verification on the hardware itself, where I've got the recorded audio, the raw audio, and I put that on its own tape, right? And get it working on the hardware. So there's a lot more work that we need to do in regards to that. Mainly taking something from data and transforming it into audio, and then writing it onto a tape. So I've got the raw audio for like lesson 1, for instance, right? I also have the data version of that, right? I have the decoded binary of the tape. That's in a .StudyBox file. That's what I'm working with here. So if I have a look at this folder, this is just one tape. So we've got a bunch of script data, we got some name table data, we got the actual sprite data, the CHR data. These are all like organized in packets and all that kind of stuff. We don't have to deal with actually doing the decoding on the audio in the emulator. The emulator just reads the raw data and just feeds it to the ROM when it asks for it, essentially. So I'm going through this the decoded data and decoding it further, disassembling it further, to see how it ticks. But yeah, so we haven't taken that and converted it into audio yet and put that on a tape. We haven't done that. That's one of the things we still need to do. But yeah. In fact, what we're doing, what we're working on right now, we're reverse engineering the format, or at least some of the details, and particularly the opcodes. Yes. Yeah. So this over here is a disassembly, I guess, a disassembly of one of the scripts, the second script for page 1. And we're going through and we're having a look at some of these unknown opcodes and seeing how they are used in the script and seeing what those opcodes actually do. Yeah. We've tried to put together our own from scratch images, but not successfully. Right. Yeah, it's probably probably the first step the next thing we should try doing is taking taking a tape, getting it decoded, which we already have, into a .StudyBox file, and then taking that .StudyBox file and putting it back into an audio stream without any modification, and see if we can get that working on the hardware. And then from there we can modify things and rinse and repeat and all that kind of stuff. Yeah. Yeah. Feeling thankful my work is in networking to storage. Yeah. But yeah, we're getting there. Using loop of magnet tape as the backbone for a network. Like Token Ring, but on tape. I think I threw up a bit. Have a really long tape loop. and kind of implement the network kind of like Token Ring or something like that, right? Oh. I had to go to make one of those tape images. Yeah, I have to find it again, honestly. But I bring my first round tape, I started learning to be a yoga teacher. Yeah. Anyway. Opcode E6. Let's see what that is. Probably run regular network stacks on that as long as they are tolerant of high latencies. Very high latencies, yeah. It's in there somewhere, Bridgewater. I know that. 10-minute data queries, no problem. Exactly. 10-minute round trip. Oh, that'd be hilarious. Oh. All right, what is this doing? Load that branch equal over to here. Otherwise, tape shenanigans. Of course, more tape nonsense. What was the other tape stuff that we were looking at before? In this one, tape weight, setup, tape NMI. Okay. So not those. Need some food? Yeah, no worries. Thank you for stopping by. Appreciate it. You enjoy your food. Okay, so this is setting up the tape stuff if it's not already set up. Fair. So is that what this is? Is this just like, hey, we've got the tape stuff set up? Will that store it? Store it. Store it. Handler tape weight. Okay. Possibly. All right. What was this last one? Tape weight. Weight on E. Something tape. What's this other one? What are we in right here? From there, probably? Edit this label. Thank you for the follow, by the way. Appreciate that. See if you can find demo tape wave BZ2 on your system. Give me 2 seconds. Hang on. Label 801C. Okay. All right. Both those set it. But one to 1, the other to 0. Exactly. So it's some kind of like status thing. Yeah. So this is either a 0 or a 1. Yeah, so this one's set to 0. Turn on NMI long jump. This... Wait, no, not that. Turn off NMI, turn on NMI. Yeah, that's got to be like whether or not the tape NMI is set up. Maybe. Because, yeah, if it's not set, it does this stuff. Which sets up the ED00, which has some tape stuff in it, right? Yeah. Anyway. Load X, argument A, decrement it. So, okay. So now it's 1. Base 1 to base 0. Load A from there, compare it to 1, branch equal over to wherever that is. Right there. Okay. This edit label, that is not 5, that is 9. Thank you very much. Click carry, add carry 2, stored there. 6, 6. Pair 1, load 1. Why does it store 1 back where it just read it? Load the thing. Is it 1? If not, okay, if not 1. Got it. It doesn't. It doesn't do that. It sets it to 1 if it isn't 1. Got it. It clears that one. Load that, store it there. What are these? How big are these? That's not what I wanted. Edit label. 7 bytes. What about this guy? Also 7. Or 6. I don't know. I don't know. Same load, yeah, different offsets into it. Yeah. Three. It's never gonna be high. 4, 7, 8. 4, 7. 08 there. 1, 2, 3, 4, 5. At most 5. No, 4, 7, 0, 8. No. So this is, I don't know what this is doing. This is setting up something. So it sets up some tape stuff, I guess. So there's arg A in some arrays. So tape NMI is set up? Maybe? Yeah, tape NMI setup. Oh, that we'll just call it that. Tape NMI setup. E6. E6. What's the difference between that and E8? More shenanigans. Use RGA as an index into arrays, and in one case stores that into one of them. Yeah. Yeah, I'm leaving it at that. We'll come back to that maybe. D5. All right, what's that one? Go there. Load A, or it with... What? Branch not equal. over to here. Load it or it. So if both bytes are the 16-bit is 0? Yeah, I was thinking of exclusive or oh my god. Yeah. Okay, yeah. Return if 16-bit is 0. Yeah. Yeah, if returns if 0, otherwise does some stuff. Right. Oh boy. Uncharted territory. Label D3B1. That's a 9. B1. It's right there. Word 442A. Okay, I need to actually set it as a word. Edit label 2 bytes, thank you. And this clears some stuff. And it fits entirely in there, so I'm going to put a comment in. But yeah. So word B1, word 42A, and byte B0. Argument A, B3, edit label. Byte B3. So a few of them change. Edit this guy. That's going to be a word. Word 4424. Okay. Wait, what the? Hang on. Whoa. Load the low byte of A, store that into B3. Load the high byte, store that into flag button left? What? B4. B3, B4 is a word, right? That to be 1 plus 1. B3. Yeah, okay. Yep. Oh, it's disgusting. I hate it. Another word here, right? No. Edit that label. Delete that label. This one. There it goes. Alright, so it's taking A, put it in some stuff. Where the hell is this used? Actually, this needs to change. Edit. That's not a 1. That's a D. Where? Find occurrences. EA. Okay. That's not a loop. D. Okay, so that skips over some stuff. This guy. Is that the RTS? Nope. That's N, though. D end. Where's this one used? Edit that label. Or let's just right there. It's a loop. All right. Load, compare, branch not equal, over onto here. Load, branch equal to loop. Is this another like wait loop on some data? Is this like a weird ass wait loop? Clear, clear. That's the end. Okay. It's the only other place it's written. What's this? Label F2AD. Where are you used? That's using the IRQ. Okay, it's waiting on IRQ stuff. Okay. It's waiting on data from tape. Thank you for the follows. Appreciate that. Appreciate it. Yeah, so this is waiting for some tape stuff. I don't know what specifically. Four 424. No, in 442A. D58 for tape. Does this? Oh yeah, uses RGate, right? 5. It's waiting for 5, essentially, right? This stuff load the argument A. Let's do this. Let's put a breakpoint there. Reset. Okay. Oh, we'll find out. Okay, so it's playing the audio for this now. Where is it? Come on. Come on. Get to it. This audio takes forever. There it goes. Okay. As soon as I started looking at it, it's like, all right, I'll do something. All right. Argument A is 5. Good. That's what I expect. All right. So we're going to step through this a little bit. Or there, it is not equal. We're going to clear some stuff. Set all that to 0. Load that, store it there. Let's get rid of some of these. Code pointer, stack pointer, sure. Byte B3. Let's see. Word 442A. Let's actually have a look at the others too. Word B1. And byte B0. Okay. Two 426. Wait, no, that's a status byte. Hang on. That's not actually checked anywhere in this loop, is it? Byte B3? Is a word there? Is it? It's one of the intermediates, yeah. I don't want a screenshot, no. That way, and then that way. Word 44. Oh no, okay, it is being read right there. Okay. Let's put a breakpoint there, and let's also put a breakpoint there. 2A is already FF. It's like a frame. Okay. That's very clear. Carry is not clear. Let's go back up to the loop. No, we're not. We're not going to the loop or to the end there. Compare that. Carry's not clear again. So we're waiting for word 4426 to equal 5. Basically, right? And that's just going to keep on going until we get some data off the tape. Okay. Did we write a bunch of crap? Those are reads. We're waiting for it to write. More reads. No, those are writes. Wait a minute. There's that 5. But this is the script we're actually looking at anyway, so that was already loaded in. But that's not in the script. Okay. No, that's the stack. That's the 5 I'm looking at in the stack. Duh. 60C. Yeah, that's that. Okay, that's the start of the stack. I'm an idiot. All right. All right. I still don't know what the hell that's doing. Thank you for the follow. Appreciate that. Push word, get byte, not equal push, not equal. Jump to absolute 6. 0, 1, 2, 3, 4, 5, 6. So this is right here is where it starts the loop. Label 6006. No. There are so different conditions to exit the loops. Not really sure what exactly it's waiting for, but I assume it's tape related. Yes. Yeah. All right. So is it? Are we looking at D5? Is that what we're looking at here? God damn it. D5. Yeah. Okay. So that's what we're looking at. Zero. So this, that is it again. It's got a loop here. And it jumps out of the loop, waits for some tape stuff. Disables a sprite. A3 unknown. A1 unknown. All right, let's have a look at those. So A3. Do I not have it labeled? All right, I don't have it labeled. God damn. CE75. Edit. CE75. No. Handler A3. That's what that is. C8A. I wonder if that's in there too. Not an E. That's a C. Oh, nope. It's part of this. All right. Is this code? Yeah, it's code too. Cool. Load up 0. Put that in that. No, this is a different array, isn't it? This might be a different array. Load X. Argument A. Okay, so 2. That goes into X. Decrements by 1. Okay, yeah. So these are these really? Is this base 1 arrays? Is that what this is? Base 1 indexing? How dare? I thought this couldn't get any worse. It's base 1 indexing. My God. Same as before, so offset 2. I'm suspecting this offset isn't really part of the array. So it'd be a different array then, yeah. A +6? Yeah. 1, 2, or 3 probably then, right? Probably 3 separate arrays. This one, and then, like, this one here, right? I don't know. Base 1, I think you understand what you're fusion. This isn't me. I didn't write it like this, all right? So just always index as 1 array plus index. Since this +6 is accessed directly instead of indexed. Yeah. Oh, yeah, I see that too. Yep. Yep. Works in C. All right. Branch equal over to here. 3 start in 6. Yeah, so that's some status thing. That's a status byte somewhere. That's gotta be. array I equals I. All right. Ew, what? Status or length? Yeah. Yeah. This guy, it's only going to be up to 3. Full for FB. Okay. Gives you access along with the right. Yeah, that's true. Yeah, let's put that in there as well. Or length value. Probably related to the array at full for FB. Hero Dev, how you doing? Welcome, welcome. How was stream? How's everyone doing? We are losing our minds, reverse engineering some of the StudyBox, this thing right here. Tape drive for the Famicom. It's got a domain-specific language on the tape, and we're trying to figure out how it works and, you know, what it does. So that's what this is up here is, as well as over here, this one here. Yeah, we're stepping through and seeing how it works and what makes it tick. How are you doing? How was your stream? Welcome, welcome. Right. Clear tables, clear sprites. What? Okay, no. Edit this. That's gonna be CE96. Store. What the? What? What? Byte 4707. Okay. Wait a minute. Edit label. That... I can't make that... What? Huh? Yes, I can. I'm looking at the wrong way. That's not what I wanted. Edit that label. That label is 1. This is the label I want to edit. That one. That one already is 5. Can be at most 5 bytes long. Okay. Never mind. I confused myself. Don't worry about it. Libinks? Am I saying that right? How you doing? Well, so conditionally clearing some stuff. Byte tables and sprites. Are these tables related to the sprites? I wonder if they are. 9.6. Okay, yeah, down here. Swap to RAM bank 0. Load argument A again. Click. We're what bank is this data actually in though right now that we're reading from? Six. Okay, so that's the. All right, so it's swapping this bank down here. Maybe. I don't know. Load argument A, add carry, store that there, trace our higher. No shifting. X4E. Okay, load that. Decrement by 1 again. Transfer that to A. Shift it twice. So this is a 3-byte array. Okay. 4E. Where's my execution? So I wanna break on that. Right at the end of D5. God, did it again. Okay. Yeah, let's go over to A3 then. Handler A3. Go to. Delete all those. Breakpoint, go. Not 3, shifting twice as 4. Oh, duh, yeah. Okay. Right. All right, where is this? Okay. So it hasn't loaded. It hasn't changed the screen yet. Is that stuff loaded, though? It is not. It hasn't even loaded in yet. It'll load it in down here, I think. Okay, so let's stop there real quick. Load A, store it there. Load argument A, decrement by 1. Load that. Branch equal. Load this one, branch not equal. All right. Store that there. JSR to swap RAM bank. So our banks are 8, 9, 4, and 5. 8, 9, 0, and 1. Okay, so we swapped out of the bank that has our script in it. Didn't we? Yeah, so our script is not swapped in right now. All right. Clear carry, add carry, store that into there. High work RAM swap. Okay, so 0, 9, or 8, 9, 0, and 1. 8E, 0, and 1. Okay. So up here at hex 5000, that changed. This changed here. Okay. Store. Load A again. Decrement. Transfer to A. Multiply by 4. Transfer to X. All right. 4EE. Zeros. But no, we're at 44F2. So we're way over here. Okay, so that's at most. It's at most 10 bytes. That's not divisible by 4. What the hell? Satisfactory is currently having a closed beta for 1.0. Oh, neat. All right. I haven't played Satisfactory in a while. Okay, so this edit label at most 10. 44EE. And most 10 bytes belong. Table of 4-byte entries. Okay. Load that, store in a Word. Load it, store in a Word. Okay. Load that. Decrement X. the deck X. Load A1. Store that into that array. Transfer X to A. Shift it. Put it back in X. Put it back in A. And push it. Okay. Load that. Four 5D0. For 5 D0 here. Not sure how big this is. But it's a table of words. Okay. Array of words. At least 4 bytes long. Length 8 since 10 would be 2.5 entries. Right. Yeah, I'll just make that one 8 then. That's not the one I was looking at. This? Alright, anyway, load that, store it there. Increment, load that, store it there. Load 7. Store that there. All right, 0E0 8E01 8F. Okay, so we swapped out the 5,000 again. Did we even read anything from that bank before? Because this is swapped out again. No, we did not. Why did we swap to this other bank in the first place? Why? It doesn't make any sense. We swap to a bank, do nothing with it, and then swap to a different bank. Huh? LSRA. Pointer shenanigans. Oh boy. All right. Well, let's dive into it. Branch not equal. These labels are all wrong. It needs to be 8. Thank you very much. This needs to be 8 as well. All right, so load 54, store that there, and there, and there. What? Ew. Zero, store it there. Okay, so it's gonna start looking at the first, all right. 496. Let's see what these actually are now. Pointer 54 and pointer 96. Okay. Load Y0, store that. 54. Right, 5400. No, load. Oh my god, load. And store that into 56. Oh my god. More pointer crap. Increment, load it up, store it. 79. What? Load that word, clear it, add that. So that's not a pointer, that's a word. It's sometimes used as a pointer. Welcome back. Load that, add, carry, store it, load it, store it, load it, store it. 547D. That is the start of some data. So is this? Hang on. No, it's not. Okay. Is this more script data though? Hang on. What's our next? 6658. No, okay. That's not our next script. And they're gonna RTS. Return. Load that, store it, load it, store it. Okay, so that's the pointer 96. Is that actually a pointer? It's a word that sometimes used as a pointer. Word 96. It's not a pointer. Pull A. Transfer that to X. Load 9A. And store it. Oh my god. Text 2. And also for particular address. Yeah. There's another table here, so edit label. Array 4511. At least four bytes. Word table at least 4 bytes long. Okay. Load that, clear out the argument. Disable sprites. Disable sprite. Singular. I don't want that. I want CPU memory. Is it just... No, sprites were in a weird spot, weren't they? The hell were they? I could have swore they were in a really weird spot. No. Okay, no, it's hex. All right. Hex 200. I mean, everything is disabled right now, so sure. We came in there, right? Yeah, early enough hasn't used any. Yeah. There's some tables. Was that a long jump? No, it was a JSR. Okay, I don't want to be in there, though. Step out of that. Oh, F11. Clear some sprites. Okay, yeah. Oh, I'm gonna jump out of that. On TS. Disable sprite, disable all sprites. It looks like. Whatever, I'll keep it singular for now. Load that, branch not equal. Load that, store it there. Okay. Byte 4715. Load it. Store it there. Swapping banks again. 8F01. 8E. So now we are back, I think, to the bank with our script in it, right? Maybe? What was that? 6,000? Nope, we are not. Okay. We're not back to that bank yet. Store that and clear more tables and sprites again, just to be sure. Okay. That was the same routine as before. Same routine as before. See what I mean about inefficiency? Like, it's calling the exact same functions more than one time. Unnecessarily. Now what is this? Label 9889. Okay. Load X that. Load A. Branch not equal. Down to there. More than one membank is involved. But it's not more than one membank. The sprites that are being cleared are at hex 200, which is in main RAM. That's not even in work RAM. I don't get it. Because, again, it calls the same exact clear sprites routine. Where was it? This one right here. Actually, these two routines, clear tables and clear sprites, they're both called. And these are all on static addresses. Right? And this sprites, this is hex 200. Yeah, these are static. These aren't pointed to. I mean, these are static. And this is probably sprite related. I'm gonna assume these are sprite related at this point, because they're being cleared right next to sprites twice even. Because that happens here. Disable sprite singular. Oh no, yeah, because it loops through them instead. Table 4B00 and 140. What do these do? 4B00, 140. Okay, so yeah, these are sprite things. These are sprite related tables. Clear. There. For the very bottom isn't, I think. Yeah. So the 4x the 4x isn't swappable. But it uses the same memory space as the next, this guy right here. These are the same. So the same memory can be swapped into both of these, but the bottom half of that bank isn't accessible in the 4x range. Yeah. All right. 9-2 transfer X. Where's my execution? Oh, not. Let me just jump into it. Load that. Load that. Branch not equal. Transfer X to A. Sorry, there. ASL it. Transfer A to X. Sure. And then put it back. Fair. Push it. I wouldn't have done it that way. I would have put the push after the ASL and then just transferred to A to X. I bet you this is like part of a macro right here. Shift A or something like that, right? I bet you. I've seen that a few times already, I think. Transfer A to X, X to A, then push A. Anyway, load that byte. Swap the high bank. Okay, so we're at 8E01. 8E01, okay. That's the only thing that really makes sense. Yeah. Oh, I didn't actually hit it. 8E01. 8E01, okay. Pull A, transfer that to X. Load, store, excuse me. Increment, load, store. Set carry, subtract. What am I doing here? What is this? That's a loop. Edit this. That's an 8. That's a 9. Loop like that. Yeah. And byte alignment? I doubt it. I sincerely doubt that. Sincerely. There's another loop here. Again, that's a 9. Don't think 6502 cares about that. Not. So there are some times that you actually do need to care about that. I think there's a CPU bug for if you get the alignment just wrong enough. Where I think it's something related to reading a pointer. Where if your pointer is at the last byte of a page, so whatever FF, or it's pointing to there, right? It won't read. So say it's pointing to 5000 FF in hex, right? Yeah, and you're doing like indexed or something, and you've got like your index value is 1, like y is 1. I think it would like wrap around to the beginning of that page instead of going to the next page to 5100, and so it'd go to 5000 hex instead of 5100 hex, right? Pointer shards, maybe there's a bug in some versions of this. Yeah, it's something along those lines. Where if you write on a page boundary at the at the perfect or worst time or something, yeah, it wraps around instead of continuing on to the next page. God, what? Was that the jump pointer then? What? Hang on. Pointer bug. No. Was it this? All right. Phantom reads. I don't think it's that. CPU reads specific address that would have side effects that change the machine's state in both states. In both cases, I later encountered definitely modes where CPU would perform unintentional reads from those special addresses. Thanks to CPU's change the details, even though the program instructions never specified a read there, it's essentially, especially a sneaky bug when examining the source code, the signal reveals nothing. And you need to break the abstraction barrier to look at the CPU actually. Okay. And some of the to control the smart special purpose disk read register. 4B. Okay. Check if the MSP is 1. Check the polling time cleaning upper bound. Program reads the special address CFF8. You also on hardware hosts the CPU by addressing that signal to the register is filled. Okay. If the program encoder ever accidentally read from CFF8, then it didn't. When it didn't intend to fetch disk data, that would create a big problem by halting the CPU and desyncing the disk bit stream. To accidentally reach to be trivial to avoid, just don't use that for any other purpose. If the code doesn't reference that, then that will be read, right? Right? Wrong. It turns out that there's a safe assumption 65C02, the second generation version of the CPU that included various improvements with the new instructions. And it's present in the enhanced Apple IIe and Apple IIc, but for the original NMOS 6502, found in Apple II Plus and unenhanced Apple IIe, it's a different story. First, freezing it during startup before ever reaching the main menu, putting all the reports together, it emerged that everyone with this problem was running an unenhanced. Someone just running an unenhanced Apple IIe system for a while. I assumed this was probably a total replay bug, but used one of the maybe use one of the instructions only available on 65C02, or relied on some ROM code that are only present in the enhanced IIe ROM. I was running without disk controllers. This is really useful specific ROM where we can begin troubleshooting. Okay, Y. Store indirect Y. So this last one there. Okay. Store 4BY. This instruction stores 1 byte from the disk into the user supplied buffer using a 16-bit buffer pointer stored at 4B4C, plus an 8-bit offset in the Y register. For reasons of program efficiency, the Y register for 2%. In using the Y register for 2 purposes at once, the code subtracts a fixed value from the pointer and adds the same value to Y in order to compensate. For example, if the buffer begins at hex D1000, then store a byte at D0F1. The code might use a Y value of F9, and the before pointer value of CFF8. On the 65C02, that requires 5 clock cycles to execute. 2 cycles to fetch the opcode and operand, 2 cycles to read 2 bytes into the 16-bit pointer, and 1 cycle to perform the write to the calculated address using the address including the Y offset. All good. Before the NMOS 6502, the same instruction requires 6 clock cycles. During the extra clock cycle, which occurs after reading the 16-bit pointer before doing the write, the CPU performs a useless and supposedly harmless read on the adjacent pointer address. Unadjusted pointer address. This one side effect is how the CPU works. I don't think this is what I'm talking about. This is not what I'm talking about. All right. Yeah. Errata. Oh, that's where I should have looked. The Nest Dev Wiki. But we, The jump indirect has the bug where you were talking about earlier. Okay, yeah. Original 6502 does not correctly fetch the target address of the indirect vector falls on a page boundary, e.g. FF, where XX is any value from 0 to FF. In this case, fetches the LSB from FF as expected, but takes MSB from XX00. This is fixed in some later chips like the 65SCO2. So for compatibility, always ensure the indirect vector is not at the end of a page. That's what I was thinking. All right. Yeah, the jump indirect. Yeah. Does not advance pages. The lower 8 bits of the specified address is FF. The upper 8 bits are fetched from XX00, 255 bytes earlier instead of the expected following byte. That's what I was thinking of, yeah. So that's the only time you'd really want to care about alignment. That, and specifically for the NES, sprites. You want that to be aligned to the page. Because of how... Or do you? Does that need to be, actually? Does it? Ah. I mean, I guess, yeah. Yeah, so it does need to be lined then. So if you're reading about is also a problem, but only with hardware registers that do something extra on read. Yeah. Yeah. Yeah, the jump indirect is what I was thinking about earlier. Yeah. Anyway, I need to hit the bathroom real quick and refill this. So I'll be right back. Don't go anywhere. Alright. I'm back. Mariana, how you doing? Welcome. Yeah, object attribute memory. Yeah, objects. They didn't use the term sprites back then. No. Object or characters. That's why it's CHR. You know, it's the character ROM. Like text characters. Anyway. DE. Okay, so this is another word. Edit. Word. 074D. Okay, but set that to 2 bytes. There it goes. I need a snack too. Give me a second. Back in the good old days, they were called objects. Objects mean something different today. Is this? Okay. Every once in a while, I get one of these, and they're rock solid. It's close this time, but not quite. All right. Oh, that clear. Add 0 to 0. Okay, yep. Turn off into my long jump. God. All right. Load that. Store that in the flag. Where's this flag used? Why do I have it as a flag? Jesus. Oh, it's one of those. Oh, God. All right. Load X. PPU buffer stuff. All right. Wait, hang on. Okay, 0010. All right. Is this buffer address, length? That's fair. Okay. Then the data. Header's high. Header low. Length. One of those students. What? Welcome, Jojo. How you doing? All right. And then load Y, do some stuff, store it over there. Word 58, 500. Okay, or 5,000 rather. So now we are buffering the data to load. So this is some character data. What character data is it? Is it this one? Page 0. No, it's not going to be 00. Because that's already been loaded. No. Page 1, I think, right? We're looking at... Is that the one we're looking at? Is that the page we're looking at? Yeah, we're looking at page 1. Page 1. 0011. CHR data. Less. Nope, it's not that. Is it? Yes, it is. Never mind. Okay, so this is the data we're looking at here. This guy. This. We're going to be loading that. Oh, so that's one of the sprites. Two of the sprites, excuse me. Johnny and, what's-her-face? Takov, how you doing? Welcome. So if we come back over to here and open up the tile viewer, it'll eventually be there. Eventually. Not quite yet, though. Let's have a look at the memory viewer first. Okay. That. So this is going to... Oh, God. This is going to do it one tile at a time. Oh, Jesus. Tile 1. Oh. C, D, E, F, 10. Jesus. Fucking scroll. Oh. More buffer data. Okay. So 2 tiles then. I jumped way too far. I don't know what this stuff was. Cool. I don't know where I am now. I don't know where I am now. Neat. Trying to catch up. Are you reverse engineering a game and trying to recover, modify an asset? Not quite. I am reverse engineering this guy. Step back. Okay. Well, I mean, I don't know how far I can step back nicely. Because I was holding that down for a little while. An IRQ hit. That's why I'm somewhere else. An IRQ hit. Oh my god. All right, we'll step forward in a second here. So yeah, so this is a tape drive for the Famicom. The script I am looking through. Not that. Not that one. It's this one up here. This script right here is some of the data that's on this tape. It's a domain-specific language that is interpreted in the ROM. So I'm going through trying to figure out what certain opcodes do and how they work. And before I was looking at just the table of opcode handlers and trying to figure out what each opcode did that way. But now I'm taking a different approach to it, and I'm looking at the script, seeing which opcodes are used and how they're used. So maybe then I can deduce a little bit of what it's doing, right? And I can see some of the data that it's using with those opcodes, right? So that's what we're doing. We're stepping through some stuff, and I think the opcode that we're inspecting right now, or that we started on, was A3. A3. I think it was this one right here. And we are in a rabbit hole of instructions and whatnot. But yeah, so I reached for the tape in here, but it's not on there. So yeah, on the tape are a bunch of programs. And yeah, you put the tape in the drive in the study box. Select which page you want. Hit go, and it loads it off the tape. Oh. several decades ago. Early 90s, I think, or late 80s, somewhere on there. No. I think the latest date on any of the chips I found was like 88 or 87, somewhere around there. Yeah. But anyway, yeah, I'll go over here and put a breakpoint right there, and bam, an IRQ happens. So we're no longer in that code. We're somewhere else. Yeah, fam comes a millennial, right? Load that. Branch not equal. Reading some data from the tape. All right, this label EF85. God, the way that this stuff is organized is so jank. Byte 07F8. This label's wrong. This label's wrong. Okay. Jenos, how you doing? Reverse engineering some stuff. Some StudyBox stuff. Stepping through using the script as a base instead of just going through the handler addresses. And look at the handlers directly. I'm looking at the handlers basically with some context. Label F1, F6. Fax, how you doing? Welcome. Welcome. How's your weekend? How's your week? Wait, 07F9. That's not equal. Load that, compare there. No, that's not equal. Load that, compare that. Load that, store that there. JSR over to here. It's on a 3. Gotta fix so many of these stupid things. Compare that. Branch not equal. It's not a 3. What's that? Oh. Branch not equal. Yeah, probably. These are not freaking 3s. Branch not equal. Down here. Jump. Oh, God. Alright, that code. Thank you. Again, not a fucking 3. Edit that. Come on, edit that. So many of these were auto-generated from Messen 1. And it uses the ROM offset, not the CPU address. It's really annoying. And this is basically a big switch case, I think, or an if-else case, or if-else block or something. Because it's looking at a bunch of different bytes and seeing if it's this or that, and doing a thing if it isn't or isn't. All right, come over there. Hold that. Compare it there. Branch equal. It's not. jump over to here. Again, F. I don't know why it has to jump to a jump to a jump to a jump. Remember you do this the other way around, different ROM, changing your labels to use ROM addresses, but I think that was because I had to code... Yeah, that was for the titler. Because it had the same exact... It had the high bank, the one that's static, at C1000 up, that's duplicated across 2 banks because of how large the ROM is. And Mesa started complaining and bitching when I use CPU addresses because it was the exact same labels in both places, so I have to use the offsets. I don't like using the ROM offsets though. Oh, that compared to 1, branch not equal. All right, another 1. Edit this. Load that. Branch not equal. Load that. End it there. Or it with what the what is this now? This random ass variable. Byte 47118. Where is this used? It's loaded once, way up here. What? Label E745 strobe controllers long jump. These are so stupid. I hate them. JSR to a jump. It's like, stop it. Why? 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 Actually, what even is... Yeah, I don't understand it. Maybe because it crosses the pages. It crosses the banks, rather. Maybe that's why. I don't know. More IRQ code? Probably. This looks like the IRQ code, yeah. Alright, so I don't know what the hell that does. Or it store it there. Okay. Alright. 42. Is that wait, actually, hang on. I've got right for RAM banks. Alright. Pausing and resuming the stream after every word. Right into the... What? So, you hit in space, and it's registering as a space in the chat box, but, like, pausing stream, too. There's the button shifting in, right? Maybe? Where was that? Down the L's. Loops and load screens and all this crap. These are all wrong addresses here. Was it F something? It's literally just this. It writes 7 to it, which, sure, technically not even a strobe. It's just write that to the controllers because reasons. I don't know. Just playing Horizon Forbidden West, and suddenly the Arch news page opened up in Firefox. Is there any new news after the XZ thing? From like a week ago. Some limit, yeah. Increasing the default VM.max map count value. That's from a week ago. Why? Huh? Just full screen the viewer and forgot to focus the chat box. Good job. Yeah, I need to play Forbidden West. I played the first one and really enjoyed it. So I need to play that one. See how it is. 50EF. Let's have a look at that. All right, yeah. So it's reading in tape data here. So this is going to keep populating then, while we're doing crap. Yeah, so it swaps to the bank that we're populating, writes a byte, and swaps back to wherever we were before. Because this is the data that we're reading into the character data. Yeah. Just finished the main story, prepping for the DLC, some maximum weapons. Game is brilliant as the previous one was. Some minor issues on Linux, some sound cutouts, some shader render lag, but other than that, running beautifully. Ooh. All right, I'll have to take a look then. Because yeah, I like I said, I really enjoyed the first one. Really enjoyed it. Anyway, put this at that. Byte 07FA. Yeah, would you guys want to see me play that on stream or no? Fire clone. Fire. Oh god, fire. It's playing playing Helldivers the other night. Fire's the worst. It just sneaks up on you. Fucking fire tornadoes. Alright. RTS. JS over to here. Some more crap. I honestly don't really care too much about this. I want to get out of the IRQ and back into the other code. Do we? No, we're still in the IRQ. God damn it. There's the end. Okay. There's the end of that. We're going to put a breakpoint right there so we can just jump to that easily next time. All right. The bats. Oh, boy. Tanky, high damage, and way too fucking mobile. Oh, yeah, okay. All right, where were we? Why it's 5, 6, 7, 8, 9, A, B, C, D, E, F, and 10. Compare that to FF, branch not equal. Is this gonna do it again? We don't have how much. Where is our buffer, actually? 302. How big is this buffer? $32 bytes. hit the end of it, though, didn't we? $328. Yeah, okay, we're going... oh, God. Alright, so it reuses... Okay, it reuses data all over the place. Cool. Neat. It's gonna do this for the entire thing, isn't it? Where's the end of this, anyway? Came in there. Where's the RTS? All right, so it wasn't that bad. Wait, nope. Not the RTI. Now it's just wait a minute. It's just waiting now? Hold up, did it? It's already started writing a bunch of that. Is it timing it? Oh my god, I don't know. DeMarcus, you have a good night. Thanks for being here, appreciate it. Alright, we're gonna just undo that. Oh, this must be like where it's waiting in the in this flag 94. Yeah, so this must be like waiting for it to actually write. That's my guess. Let's come down to there. Good. So this was edit that. Is that at 9? Yeah, it is at 9. Okay. So right there, and the swap. We did swap one of those. All right. What's this? What the fuck is this? What is this? These labels are all wrong, number one. Label 982. No, 98828. What do you mean a label with this name already exists? Excuse? How dare? We're gonna do some of these. This needs to be a 9. Loop. Another loop, right? Yeah, there's no loop. 9 loop. And now is where you find out that there was a reason you had ROM address. These, I didn't put these in manually. These were auto generated from Messon 1, I think. Because these I would have had underscore loop in them. But I mean, sure, but I don't like the ROM address ones. You know? Another 9 loop like that. Edit. Like that, a 9 loop. Load A, load X. Store A. The 7D. All right. Label 99828. Clear tables at 4E00. For C80. For D80. 6500. 6600. Where else? And 6. Okay. Edit label. And 6. All different lengths. Sizes. No. See, messing and looking at GDB makes me fucking cry. I'm sorry. Now that I'm cleaning ahead of my outside time, do some bot bug visits, then spread democracy. Yeah. I'm gonna be spreading some democracy later tonight. Yeah, I found. I think I found a playstyle that I like with the bots. That I want to expand upon tonight. What's this? Is this a spoiler? I think we should spread democracy together. Sure. So I can't believe how fucking strings fixed my 2x issue. That may not be a kid. Don't worry about it. It's fine. I don't judge. All right, so I'm gonna tag that. Okay. Democracy. Yeah, the quotes are on the democracy. Yeah. Well. Hear that. Oh Jesus! More pointer nonsense. Yeah, this is the pointer stuff you were talking about on Discord, right? Where it was like some weird address nonsense, or the pointers were changing when they should have been changing, or something like that, right? And you had a memory leak essentially. Yeah. So went away from pointers back to strings. Yeah. Yeah. Some C++ shenanigans. Some bullshit. People wonder why no one likes to use C++. Oh no, string C++ is a pain. Yeah. Memory leak was the result of the pointers being funky. So, I haven't seen it in a while, but so we've got these like training videos at work, right? That are as dumb as you think they are. One of them was, so a lot of them are, you know, don't date your coworkers and that kind of bullshit, right? And lock your computer when you get up, and you know, don't launder money. This is how you launder it, by the way. There are a lot of that, right? One of them, out of left field, right? One of the training videos dealt with memory leaks in C++. And I'm like, huh? Huh? And it was like, it focused on like, balance checking arrays and crap. And I'm like, okay, first off, we don't use C++ here. That's number one. Number two, that's like hyper focused into a very specific memory leak. What? Why? Why? It sounds like, it feels like, you know, one of the higher ups saw this training video and went, oh, we have programmers. They need to take this. Not understanding that, like, it's completely unrelated to anything we do. You see ChatGPT or something won't let you ask about C++ because it's not safe. Yeah, no, it was wasn't safe for children or something like that, right? So it refused to Yeah. Why can't you date so it a bit more nuanced than that. It's more of not dating one of your subordinates or vice versa, right? Because there's a power dynamic there. The whole conflict of interest kind of thing. That's what it really was about. That's okay. So you've heard stories about the bullshit that happens at work. We need to say the obvious things because not everyone thinks they're obvious. Do any language you use even allow that kind of memory leak? Go doesn't. Go will yell at you, be like, "No, stop it." PLB. Normally, no. However, Sunbelt has some fuckery where you can dynamically allocate shit. That has some dipshit that used to work here tried using those, but poorly, and it broke all kinds of shit. Yeah. That's true. I just got to ban it because it did stupid things with Go. Yeah. Can you do memory leak with pointers? Sure. The issue with PLB isn't memory leaks as PLB. Yeah, but so as far as the standard is concerned, memory leaks aren't possible because everything is statically allocated at the very beginning of runtime. And after that allocation, nothing else can be allocated. Or deallocated, for that matter. As far as the runtime is concerned. However, with Sunbelt, they added in some dynamic allocation crap that throws all that shit out the window. All right, the fuck Sunbelt extensions, yeah. Oh, yeah, oh god, yeah. So if there's no safety around them. It's just, hey, here's some pointer stuff. Don't break it. Good luck. So it's incredibly easy to break. Like, ungodly easy to crash the runtime. Like, so normal errors in PLB are, hey, you did a bad thing, slap. Here's the error code. When you fuck up with pointers, it's Windows going, this program did some stupid shit, I'm killing it. PLB doesn't even know it was shot in the face or the back of the head, I guess. Right? It just dies. And Windows goes, no, we ain't doing that shit. Fucking stack trace and all that kind of crap, too. Yeah. You can do memory leaks and Go at least with plain pointers. Oh, there's an unsafe package though, so you can find a way, I'm sure. I mean, even in Rust, there's the oh god, what was it? The safe leaks or something like that code where someone using only safe code memory leaks or leaks memory all over the place. Yeah. Because long-lived references, cache map, unused block Go routines, and CGO or unsafe code. Yeah. There's some forms of memory leaks Go can do, but I think most of them count to keeping around pointers you don't intend to, thus not releasing stuff you don't actually need, but the GC doesn't, can't tell us you can't, so you can still reach it. If you go full and safe, yeah. There's ways, yeah. There's absolutely ways. CVERS, that's the one. That's the one. Which is abusing a known compiler bug. Yeah, all right. This the sync pool and you never return the pool. The second message, what is that? You can do memory leak pointers. Can't do memory leaks and pointers and Go, at least not with plain pointers, because long living references cache. I read that. Memory leaks and Rust are no abuse. How you doing? And Exova? I don't know how to say your name. How you doing? Real-time processing. You said unless you do a safe code and then you just read, and then you read. Oh, okay. All right. Such an annoying bug to fix. They're waiting until they get the new borrow checker in the compiler. Stream delay. Gotcha. Stream delays. Got it. Got it. Anyway. This is one of the bytes that was cleared out, wasn't it? Part of the table. Yeah, the very first one. Right here. That it incremented to 1. For E00. On the one hand, I like the Rust. And on the other, fuck that. Yeah. Thank you for the follow. Appreciate that. Actually, this guy here is actually a table, technically. 125 bytes, or 124. Table 4E01. I don't feel like typing it. 124 bytes. Rather than Zig than Rust, I think it's Zig. That's one of the ones I looked at on stream a while back, right? What's something called Polonius? I am studying StudyBox. How you doing, Sir Kane? Welcome. It's either C or Rust. I'm sorry. That's unfortunate. Zig, I think I may have looked at both. I don't remember. I think I have Zig installed. I've got Zig installed. I know that much. Yeah. I don't know about VLang though. One of them I shadow over. Was that VLang that I just didn't? I had nothing good to say about. Was that the one that? Yeah, VLang. Yeah. The one that the compiler errors were all like C stack traces. And I'm like, what the hell is this? Oh. I found more and more issues the more I dug. Yeah. Yeah, where it was a transpiler from V to C, and then he used GCC on that or something. But it used, like, templates out the ass. So when you tried to compile something and it didn't work, you got a useless stack trace that was into some generated C code. And I'm like, what the hell is this? Or C++ code. And I'm like, what the fuck is this? Huh? This doesn't mean anything. I think it was auto-free, which is pure BS. I also didn't remember most of it. The broken... Yes! The broken sandbox. Yeah. Where I was copy-pasting code examples from their documentation and pasting it into their sandbox, and it threw an error. And someone had pointed this out, or pointed out, like, my stream or whatever on Twitter, back when it was still called Twitter. And one of the main devs, like, responded and said, don't use the sandbox because it's not up to date, or whatever. And I read, and then I responded to the dev, and I'm like, then take it offline. If it's wrong, it's giving people the wrong impression. It shouldn't be there. It's still called Twitter. I mean, to be fair, I refuse to call it its new name. I refuse. No. I do because math. Are you overloading int plus int? I'm assuming he's overloading like vector math or something like that. The site is still Twitter, i.e. the URL. That's fair. That's true. That is true. As soon as he changes that, suddenly all kinds of links across the internet die. And and no one goes to his website anymore. Yes, vector math. Yeah, that's what I figured. Where you overload an operator to work on like objects, essentially. This object plus this object. So you overload it to be like, no, what I really want to do is, you know, this function over here or something, right? Yeah. I mean, it has its uses. It does. It's not just like on a plain int or whatever. I mean, you could do that, I suppose, but yeah. Vec 0 plus Vec 1 is nicer than... That is true, too. That yeah. It's easier to read. That's for sure. Anyway. Oh, Jesus, what is this? I'm going to ignore that. I'm ignoring it. Edit. Label 99995. 5. I've loaded equals my location struct in a vain effort of fixing the pointer scrubs. Such a small problem for all the pain the operator overloading introduces, though. I think it depends on your use case and how you use it. Person overloads I can't get behind more. So you don't have a function overloading. So you will need to have vector effect 1 and effect add scalar val. Yeah. Yeah. So instead of having like a billion different functions and having to worry about which one to actually use, it's just the plus sign. Yeah. All right, I'm going to step out of that. What's this? Why is there what? Where's that loop? I want to see how large these are. Decrement pointer. Fantastic. I have no idea how large they are. Edit this. Label 8E63. 8E63. By abusing traits. Well, technically. Technically, anything's possible. Generic method functions. Does it not? I haven't dove too much into the generics, by the way, so. Vecna? Am I saying that right? The head of Vecna? What? They didn't add it because there were some complexity on unknown cases or something. It was going to be added, but they decided not to. Okay. Embrace functional programming. I still need to, like, you know, learn some functional language properly. And use it for something, you know? Buffer move. What? Oh, Jesus. Label DD2B. No OOP objects. So for that, clear those again. What is this one? Wait. What? Oh, no. 10, restore previous RAM bank. Okay, RTS. Oh, this is the, what's it? The engine part. This is the engine. Yeah. Mm-mm-mm. 416. Where is this? RMB check. The loop. What are we doing? Stepping through the interpreter to decipher the DSL again? Yeah, pretty much. But I was using the actual script as a like starting point, I guess. Yeah. Did I actually change what A3 was? Did I name that? I don't know if I named that or not. Come on, get up to the H's. There it is. I did not. You have a working study basic disassembler yet? That's what I'm working on. That's what this code over here is. Yeah. Main reason Rust has operator overloading, but not function overloading, is because of how the type inference works. This operator is done via traits, which is why you can use traits to actually have overloading. Oh. Yeah, it's working, just not really complete. Because we're using this as like a, you know, we're working on it as we go, right? So we got a lot of things that aren't defined yet, like, you know, a lot of instructions that aren't really defined, not really finished yet. Did I do E6? I think I might have. I did. Okay, so let me redo that. There it goes. So now that guy's in there. How many unique instructions? Like 127 possible. Thank you for the file. Appreciate that. Yeah, so anything under hex 80 is a value and not a function or opcode or whatever. Yeah, kind of. There are a bunch that have inline values that can be anything. Like this one. I mean, that's higher than hex 80, but it's part of the part of this opcode here. Is it? Actually, I might be doing that wrong. I don't know. I might be doing that wrong. Maybe push string. What is page 1? 0003. Where's the BB in this? It's gonna be right before this. I am doing that wrong. Okay. It starts out with 55. Is 55 the slash? Five is U. What? Unit. Oh, the XB. Okay. Yep. Okay. I see. I know I'm doing wrong. I know I'm doing wrong. That's better. Okay. Argster, that is incorrect. That's better. Okay. That's better. Such values just get pushed onto the stack or something? Yeah. Kind of. I mean, they get pushed into a certain... Actually, I don't know. I don't remember. It might be a special spot that's separate from the stack. I honestly don't remember. Oh. On top of learning, I think I would rather play with some other container systems that are different from Docker. Just know more about it. Huh. I need to start learning AWS soon. Because we're going to be using that at work, apparently. So that's going to be fun. Oh, yeah. So... So at work, I actually rewrote a program, most of the program, in Go. One of the jobs. It's one of the simpler ones that uses that GMC or Inspire Designer bullshit, right? So the original PLB code was just like the orchestrator, moves some files around, kind of, and called programs. So I converted that. Not one-to-one, but I converted it to Go, mostly. So some stuff I need to figure out. And I tried running it. Or I was running it as I go. I can't run it on Linux, but not for the reason you think. For some reason, running on Windows works fine. But if I try to run on Linux, on the last step, Inspire goes, no. No, you don't have enough licenses. I'm like, the fuck you mean I don't have enough licenses? Go to hell. The shared drive thing? Maybe? Does anyone else remember this brilliant 1-hour video where they code Docker from scratch? No. Like they like roll their own Docker equivalent from scratch? Like that? Yeah? Oh. That sounds interesting. Doesn't Docker just like wrap the KVM API essentially? Red Sly Fox, how you doing? Ghost Code for web dev stuff. Yeah, and I don't use it for web dev. I use it for other stuff. Like this. I'm using it to disassemble some weird domain-specific language. Docker and KVM are completely different. Okay, fine. KVM, that's VMs, not containers. Docker is essentially a fancy CH root. All right. Maybe I was thinking of a different one then. I'm just noticing now that there's a space at the end of these. Why? Why is there a space at the end of these? What? Because that's going to do a lot. Two. These are Huh? Wait a minute. Push word doesn't have a word to put. What the what? Did I break something? Probably. Not R, Control R. I had broken it. I broke it when I when I changed that. I broke it. I fixed it though. B8 has an inline. All right, it's push a word, so you'd think it would, wouldn't it? Oh. Push word to stack. Yes, it's in line. You disassemble the assembly. From there, you can lift C. Oh, but that's advanced technique and tricky to get right. Yeah. Isn't assembly disassembled into C? No, no. That's decompilation. Decompilation? If I can get my enunciation correct. Load Y decrement. Yay. Load Y decrement. Not how many hours is it? Not exactly Docker. That's it. Okay, 20 minutes. All right. Build a container from scratch in Go. Oh. I'll have to watch that later. Save that to my watch later. Thank you. Yeah, disassembly goes from binary executable to assembly. Right. So I'm disassembling, not decompiling. Yeah. There's also this. What's this? Build your own container runtime. Oh boy. Yeah, well, that one's a half an hour. I'll save that one too. Watch that at work or something. Anyway, I am running out of steam. Thank you for the follow. Appreciate that. I'm running out of steam. I'm getting hungry. I need to get some food. So we did make progress. We actually made some decent progress today, I think. I'm gonna jump work and watch YouTube videos. I should be doing so. I found out this past week that at work, Spotify is blocked because, oh no, it's a streaming platform. We can't have that. You want to know what isn't blocked? YouTube. The largest streaming platform on the planet is not blocked. I even brought this up to IT and then realized, I'm like, wow, this is probably a stupid idea. And I'm like, yeah, this doesn't make any sense. He goes, oh yeah, because streaming, you know, what is it? It's high bandwidth. And I'm like, it's just, Spotify is just audio. That bandwidth is negligible. What the hell are you talking about? Especially if you don't block YouTube, which is a lot more bandwidth intensive. He eventually comes back with, oh, well, so we got training videos on YouTube or something. Sure, whatever. I'm not going to push that. Because I realized that, oops, I might accidentally get YouTube blocked. I didn't, thankfully, but... I read up on stuff at work when I have to wait. Because I'm going to have to probably sync a 2 terabyte repo tomorrow morning. Oof, that does not sound like fun. Dangerous to listen to Spotify? So, for whatever reason, at work, static electricity is a problem. I guess because of all the fucking paper dust in the air or some bullshit. It's really dry. So, whenever I stand up and touch something metal, I zap it. It's to the point right now where, so I've got my setup, right? So I've got my laptop, docking station, 2 screens that are plugged in the docking station. If I stand up, not touching anything, my desk or anything, just from the chair stand up, my right screen will turn off and then turn on after another second or two. I don't know why. My coworker didn't believe me until I did it in front of him. He goes, what? I'm like, yeah. That ain't supposed to happen, I'm pretty sure. Something ain't grounded and or shielded correctly. Also, I've got wired headphones at work, or earbuds, which is a problem. Anytime I shift how I'm sitting at work and I have those in, zapped, fuck. It's happened numerous times. And I believe that is the reason that the speakers on my laptop no longer work. Almost any airborne dust is explosive? Yes. Can I? Oh, easily. I can easily use a proxy to get around it. And the only reason I was looking at it, by the way, because, like, currently at work, I listen to music on YouTube. But I'm not against, like, you know, giving money to a service that is specifically for curating music. I'm not against that. So I'm like, okay, well, maybe, like, can I try out Spotify? try to go to the website and goes, no, you can't. Fuck you. Like, oh, all right, cool. For me at work, it is trivial to set up a proxy for it. So I'm a software dev there. I'm the only Linux guy there. No one else really knows Linux. They know like how to make a directory and change directories, and IT kind of knows how to create a user sometimes. They had the script that was to create a clone of users, so it fucking duplicated the entire home directory, which is stupid. What the fuck? I appreciate that. But like it would also clone the groups, the users groups, but did it wrong. So some groups have fucking spaces in them because Windows bullshit somehow. So the script broke horribly. It got to the point where I was receiving IT help calls from IT where they're like, I broke it, what do I do? You know what's bad when IT is reaching out to non-IT to fix an IT issue. So I disabled that script, and I got a big message up top that says, do not use this script. Just use the fucking commands directly. There's 3 of them. Fucking A. Or 2 of them. I don't know. Like user add and then like password. Use those, damn it. Oh, yeah, it was password twice. One to like set the password and then again to expire that password immediately. So the next login on that account, you're forced to change it. Yeah, so 3 commands. Not hard. I'm using the skeleton directory as it was intended. So we don't have to fucking change this and that and this and copy fucking home. No, stop it. Just change the skeleton directory and you're done with it. Give them PowerPoint guys for PowerPoint with its references. It was references, yeah. You could use the work servers as a remote storage and no one would care to find out. Someone might, because we run out of storage frequently because nothing's done correctly. But anyway, what I'm getting at is, so I unofficially manage the 2-3 Linux servers that we have. So anything goes wrong, I'm the one to fix it, right? And the head of IT is brain dead when it comes to Linux. Brain dead. So I can sneak anything by him. Because he just doesn't care to learn, or he's just too stupid to. Yeah. Yeah. The wire that went to the switch was attached to the ground plane somewhere. Ooh. It just shorted everything? That's good. Yeah. Yeah, but I still remember, though, like, explaining to IT, all of IT at once, like in a group call, or, you know, whatever, conference call, what TMUX was and how it worked. Because I was using it. I started using it because shit was breaking and disconnecting. So I'm like, fuck it, put it in a TMUX session, and it stopped breaking. It still disconnected, but it didn't break when you reconnected. Or when it disconnected, rather. Right? So that confused the shit out of them. Like, what is that? Is it a server? What? Huh? Is it an extra program you're running in a... No! It's a program on the server that's running. Ground plane to nothing. Open air. Not a short. Oh! It turned into an antenna or something like that? So it only had one wire attached to it, so it couldn't have done anything. And that wire was attached to ground, so it couldn't have done anything. And yet, it crashed the computer. Some weird electromagnetic field that happened or whatever when it switched. I don't know. Put your music on your phone and then cut out Spotify and Sirius. No, I'm far too lazy for that shit. Far too lazy. That and I do not have enough space on my phone for the music. Give me a sec. Hang on. I'm gonna find one of my collections here. So this one? That's it. $32 gigabytes of Eurobeat. This is only Eurobeat, nothing else. From like 1994 all the way up to 2013. How many hours? A few. So I started listening to the start of this, Volume 1, last year in January during my commute. My commute, one way, 20 to 30 minutes. So roughly an hour a day. And any other time I was in the car, it was going through this, right? 4 months later, I was still listening to this. And I wasn't even halfway through yet. So, a few. Few or two, how you doing? I don't know what 2x is. I don't know. If I didn't use it, I probably wouldn't get the explanation. It's kind of a strange concept. I mean, I guess. I don't know. I had a tough time explaining it to them, though. He was fixated on it being a replacement for putty. And I'm like, what are you smoking? Might be better to ask how many days, 24 hours of music. I cannot answer that question. I don't know. So let's see. Open here. Find from here. I name start at MP3. MP3. Oh my god. Pipe that into WCL. No. There's more than 18. There's way more than 18. What is this finding? Okay. 5,000 songs. At, what, 3 minutes a pop, say? Just for shits and giggles, right? So we got 3 minutes times 5113. 15,000 minutes divided by 60. 255 hours. 10 days. 10 days of music, straight. Read your story. What story? Oh. Last week I got an email from the IT department of the university. Zoom data deleted. Read the title and thought that they finally ditched it. Read the mail. Nope. They screwed up and deleted all data on accident. How many gigs? Like 23? Or 30 something? I don't know. 39. 39 gigs. Right up to 40. You have one big RPG playthrough around amount of hours of music. Yeah. And the worst part, there's duplicates in here. I know there are because I've listened to half of this shit and I heard the same song so many goddamn times. It's the Windows user problem. If they didn't use Linux, they probably can't understand how the system works. Yeah, they are very much Windows users. All of IT, they are brain dead when it comes to anything Linux, and it's so frustrating. Oh, right, DU. I should use DU. HSC, I don't usually use those. Because this, right? Yeah. I don't know what the asterisks are. Next project, remove duplicate MP3s from a music collection, right? I need to script up something like that. The first does it by just like hashes, just to see if there's identical files in there anywhere, because I think there are. I think I've done that check, and there are actually identical files. But like with different names. And the reverse, like the same name, but different hashes. Yeah. Probably get started editing some music files. I have like 600 songs to add metadata to. Whoa. Wow. BSCH, because I want data size, not disk size. Byte? Why do these two come out different? Just swapping those two around. Still, that was close enough. So you're rocking Alex the ERCE. Did you try some window manager? I'm using XFCE. Yeah. Only because it just doesn't get in my way. Although I found out, because of course, that this will actually get in my way. This is broken in a recent update. I don't know why. And it's just this terminal emulator. It's just XFCE terminal. That's why I'm using this. What the fuck is this one? This is URXVT. It's a mouthful. Yeah. This one works fine, but this one doesn't. I don't know why. I don't know why. See, it even screwed up this crap over here. Does that highlight actually? No, it doesn't. It works fine here. Kitty or Alacrity, they're amazing. Are they terminals or? Because honestly, I'm not too concerned about like the actual terminal itself. I don't do ricing. I don't care. I don't care about ricing stuff, making stuff look pretty. I do not care. I just want it out of my way. That's all. And I don't. And tiling window managers are not for me. For a few reasons, but they don't work with my workflows. So yeah, I just need something to get out of my way. That's the only reason I'm using XFCE. Vim keys are integrated. Okay. Well, what do you mean Vim keys are integrated? Because like I've got Vim keys on the console. Do I do a lot of stuff in C? No. I know a little bit of C and C++. Enough to make a mess. I do more work in assembly and Go and PLB. Yeah, using Linux does not mean knowing C, right? Yeah. Yeah. And no, I'm not a web dev before you ask. I hate web dev with a passion. But yeah. I use Linux because I enjoy using Linux. It doesn't get in my way like the dumpster fire that is Windows right now. I'm forced to use Windows at work, and I fucking hate Windows 11. Oh my god. It just does not know how to get out of your goddamn way. Yeah. Yeah, and Jill also makes a good point, yeah. Not a good market for web devs right now anyway, yeah. Yeah. I'm probably stuck where I am for a while, honestly, but Haven't had any issues with Windows 11. So for me, Joe Mega, with your work machine, I can guarantee you it is a lot beefier than the piece of shit that I am given. Guarantee it. A lot of the stuff I have issues with is shit running slow and straight up fucking crashing. Like if I try to copy from one Windows share to another Windows share, and if the file's too large, my network card goes, never mind, and stops working. And everything on the computer grinds to a goddamn halt. Everything stops working. Explorer, fucking Adobe, because fuck you. Everything comes to a hardware. It comes to a grind and a hard stop. It's easier to hold the fucking button down and restart the damn thing. Work PC is Intel waste of sand generation. 128 terabytes of RAM. Yeah, and a 3070. I've got a laptop on a docking station. It's got 16 gigs of RAM, I think. And, I don't know, an older i7, I think. Gigabytes, not terabytes. Okay. DeFury, how you doing? Welcome, welcome. Okay, Windows XP, oh my god. Air gap for operating the panel saw. I had the machine crash on me 8 times last Wednesday and only ran it for 3 hours. No, my god. That's terrible. Why the hell can't they turn down the brightness in Windows? I can, but because it's a laptop. And only on the laptop screen, actually. So, yeah. But yeah, I hate Windows. The more I use it, the more I hate it, honestly. To the point where, like, yes, I could do XYZ in Windows, but I'd rather SSH into the Linux box we have at work and do it there. I do need the 120 gigs. Yeah, I can see that. Yeah. I mean, for what you do, it absolutely makes sense. But, yeah, so for me, like, oh, God. I could actually probably use more RAM. But then again, like, the programs that I need it for, like, you know, Adobe Acrobat, it's a fucking 32-bit program that I've got installed. I need to install, like, the 64-bit version if it exists. But yeah, so like a lot of the data that we work with at work is in PDF form, and I hate it. Pix capture frame can be a couple of gigs. Apparently, the snipping tool can't handle my screen setup. It glitches out. So I'm using Xshare because the Windows snipping tool suggested I send shit to its AI for reasons, and I went, never mind. So I installed Xshare, and through some shenanigans, I changed the keybind to Windows C, which, as you can see, is the exact same keybind I have here for a screenshot. Discard. Works beautifully. Discard. Will this crash? It didn't crash. Okay, cool. On Windows, it's laggy as fuck. I'll hit the key combo. It'll do something else half the time. Like open up the little fucking Teams bullshit. Not the Teams app, but some like Cortana-esque Teams nonsense next to the start menu. And I'm like, what the fuck is this? Close that. Hit it again. Then after a second, sometimes 2, Xshare's like, I got this. Gives me the crosshair. So then I click and drag. It lags for a second. So when I dragged, it started at where I ended. And I'm like, what the fuck? Huh? So frustrating. WinShift S is snipper tool. Yeah, that's the one where it's like, hey, we're gonna send your stuff off to an AI. I'm like, fuck no. So I stopped using it out of principle. Yeah, then Adobe is like, you know, shoving this AI bullshit down your throats too. Because I've already ranted about that one on stream. Don't know how the hell that happens. What, the AI bullshit? Yeah, I don't fucking... Oh, God, I hate it. Windows has turned into adware. Windows is a fucking virus. I hate it so much. I hate using it. I haven't used Windows for enough years now that I don't really know much about it anymore, but the more I hear, the less I feel inclined to go back to it. Yeah. So, years ago, the experience on Linux, for me, if we're using it as a daily driver, was kind of rough, right? Not everything would work, and like I couldn't play like all the games I had on Linux, right? Or getting them to work where they worked not as great as on Windows. Hang on. I bought and installed this last week. 0 modifications. Just fucking works. Just works. The vast majority of my games just work. A few of them I need to tweak here and there, but they still work. I'm not going back to Windows as my daily driver. I'm just not. I'm not. It's not going to happen. No. I even stream from Linux. Like my stream machine is all Linux. It's using a hardware capture card that's capturing this other machine over here. None of my workflow here is Windows. I even, in fact, to install this, I deleted my Windows partition and reformatted it as ext4. I think it was ext4 anyway. As a Linux partition. My Windows partition is fucking gone. It's gone. I don't have it anymore. In-game dev, I don't want to move to Linux. Hell no. I mean, I get that, yeah. One of the reasons I use it, DirectX. To use what? That's what was when 8.1 just came out. 8.1 was the last Windows OS that I had on any personal device. Yeah. Just reminding about XP. There's a coworker that would rant and rave about how XP was the only best operating system ever, no matter once. Oh my god. He also would move out of .NET Framework 3. Oh, so quick little story on .NET Framework stuff, or .NET stuff. So that little UI I wrote up in C# this past week, I wrote it in .NET 8, right? And got it all working on one of the servers. So this UI is for a PGP tool that we have. Proprietary as fuck and licensed, because fuck you. Which means it can only run on the service it's licensed on, or the machines it's licensed on. So I can't run it on my machine, basically, right? And it's a command line program, which is a pain in the ass to use because it does stuff stupid. Just don't worry about it. Don't worry about the details. So anyway, I wrote up the little application, this little window, choose file, decrypt, basically. Or choose file, give it a key name, encrypt. That's all it really does, right? The other machine, so that was a Windows 10 machine. The other machines are Windows 8 or 8.1, the server version of that. So Windows 2012, right? Windows Server 2012. And I'm like, okay, well, I sincerely doubt these have .NET 8 on them. So let's go back to .NET 5. So I made my changes, I had to change some things here and there in the C# code because stupidness. Get it over on that other machine. Try and run it. .NET's uninstalled. What version? Any. Huh? It's just not. Gonna be the worst thing that causes shit to happen to Windows? Corporate. Yes. Yeah. Not sure. I think XP was the last one I used. Not sure if 7 was yet out or not. Not yet. 7's all right. It was all right. 7 was better than XP, and 10. Not sure about Windows 11. I hate 11. Works. It does not work nicer for me. It works worse for me. You know. I originally had 10 on my work laptop, and then it upgraded one day to 11 in the middle of the day. Thanks. And it has run worse since the upgrade. Personal experience also really affects which. Yeah, it does. Yeah. Doom Solo, how you doing? I've been on Linux as a daily from 08-ish till I switched jobs in 19. Been forced to use Windows as a daily since. Yeah. Yeah, everyone's experience, everyone's mileage varies. Yeah. But yeah, I mean, I'm on. I daily drive Linux, and I have been for a few years now. But yeah, I don't see myself going back to Windows ever, as on any personal stuff. I mean, I'll use it at work because I have to, you know. But yeah. Excuse me. I'll do it if I have to, but I don't want to. I really don't fucking want to. But anyway, I'm gonna wrap up because I am hungry. I need to eat. We're gonna see if there's someone else live though that we can go say hi to. Work is what I meant for daily. Okay. Home machines. There you go. Yeah. Yeah, my work machine. I don't consider my a daily driver. That's my work. That's the work machine. I do not own it. It's not mine. It's the company's technically. Hey, what the fuck? I appreciate that. So the only machine that I have one machine that I own that runs Windows. It's Windows 95. It's on some massive brick of a laptop back there somewhere. Yeah, I need to fix the power cable on the thing because it's frayed as shit. So I need to like redo that a little bit, so figure out how to fix that and not make it a fire hazard. Maybe I'll do some stuff on that, get some stuff working on it or something. I don't know. I think Doom is on that. I do not use it. It's away in storage right now. Like I said, the power cable's frayed, so I don't really trust turning it on for very long. Battery doesn't work because how many years old is it? I don't know. World of Warcraft and some other games work easily on Linux and switch over, but I don't want to bash my head through getting them to work. Yeah. I mean, if I really need to do something on Windows at home, I've got a VM for that. That's what I've got for my audio interface that I still have to get around to figuring out how to write drivers for. We'll get there eventually, maybe. I don't fucking know, unless someone else gets there for me. But anyway, I need to go eat, so we're gonna find someone to go eat. Find someone to go eat? No, we're gonna find someone to raid so I can go eat. Find someone to eat. Oh, God. But yeah, thank you for stopping by. I do appreciate it. Do I have any resources for reverse engineering learning, or even for mobile, or just in general? Not off the top of my head, I don't. There some on this? There might be some on Discord. I don't have anything specific for reverse engineering, I don't think. Yeah. We are here to eat you. Thank you, Jojo. Appreciate that. All right, let's have a look at the category. If Twitch, there you go, Twitch loaded. All right. All right, who can we go say hi to? Unity stuff, no. Unreal, no. No. Anybody doing something different? Anybody doing something different? Birthday weekend. Someone's having a birthday. More Unity stuff. A lot of Unity crap, you know? Some Godot. This guy's making a game. Making his first game. Let's see what this is. Let me turn capture off, though, so you can't hear it. Come on. Is it going to load? I did turn the capture off, right? For that? Yeah, okay. Can't hear anything. Hang on. Anyway, I think we're going to say hi to this guy. No idea who he is. Just want to make sure you speak English. Give me a sec. Yeah, it's probably fine. Anyway, come on to me to say hi. I would appreciate it. And yeah, I'll be back next weekend. Doing, I don't know, something. Who knows? We'll figure it out. Yeah. Join the Discord if you haven't already. Over here. And yeah, I'll see you next time. You guys have a good night. Let me hit the buttons and do all the things. Bye-bye.